Hi, my name is Jonathan Hopp and welcome to Coding Your Career. Today we're going to build an API using Spring Boot and Spring Data JPA. This is a 4.5-hour course, so we're going to go through everything and give you all the tools you need to actually build your own API. I am making a couple of assumptions for people who are taking this course. So first off, you need to have some basic knowledge of Java. If you don't know anything about Java, or it's been a bit of a while and you need a little bit of a refresher, then I do have a free Java course on this very channel. Other than that, you will need to have Java 17 installed. You'll also need MySQL Workbench, and you will need IntelliJ Community. If you have IntelliJ Ultimate, that's fantastic, but IntelliJ Community is free and available for everyone. Other than that, you should be set for the course. And again, this is going to be the full course, 4.5 hours. If you enjoy this course and you would like to see more content like this, I have a website called codingyourcareer.com where I have courses on TypeScript, JavaScript, all sorts of courses on front-end and back-end development that you need to succeed in your coding career. All right, without further ado, let's dive right in. Let's start building our API using Spring Boot. Getting started with Spring Boot is actually pretty easy. We're going to go to the Spring Initializer website at start.spring.io. You can Google it as well, and you can get straight here. So the Spring Initializer essentially is a nice GUI in order for us to get our Spring application set up with the proper dependencies. Again, it would be really awful to try to do this all by hand, so we have this nice website. So obviously the language is going to be Java. We're going to choose Maven as our dependency manager. We'll do 3.3, that's fine. And we'll call this, go to artifact, you can say my first Spring app. Okay, something like that. Right, you can add a description. This is just for, metadata about the project and packages and names, all that good stuff. We're going to do jar, and we're going to stick with Java version 17. If you want to use a higher version, that's no problem, but I'm just going to do 17. And then the main event is add dependencies. This is where the fun starts, because you'll notice that we have lots and lots of different things we can choose from. And this is cool. Like, every Spring application is a little bit different, has a little bit different need of dependencies. You might be doing reactive Spring. You might be doing a website, like an MVC kind of app. You might be making an API, so microservices. So they let you pick what you want, and then you can kind of just go from there. So we're going to search for Spring Web, because we're going to use that because we're going to make a API. So we're going to need this in order to do that. We're also going to do Spring Data JPA, because that is what's going to help us talk to the database. Well, it gives us a nice API to really make SQL very, very easy to work with. Speaking of SQL, we will need a driver. So we're going to do the MySQL driver. And this is important because, well, we are going to talk to a MySQL database. Okay, so if you want to talk to the database, you will need a driver. And then we're also going to teach you how to use Lombok. Lombok is, I'm not going to lie, it's controversial within Java circles, but I do think that it's good to learn it, all right, to understand what it does. It helps cut down a lot of boilerplate code. I don't know whether or not your job will actually allow you to use it. Some places love it, some places ban it. It just kind of depends. Now, just to kind of show you that there are other dependencies in here, there's so much stuff, right? Because you don't have to use MySQL as a database. You don't have to be writing an API. You might be writing an MVC app. You might be doing reactive job, like reactive Spring, which is kind of cool. And so you have, the sky's the limit. You can basically pick, Timeleaf is a pretty, if you're doing an MVC app, Timeleaf is a templating engine, which is pretty cool. Spring Security allows us to secure our application in different ways. You have OAuth 2, you have a bunch of different stuff, right? So you have different libraries in order for connecting to the database, and you get to choose, right? You might be doing SQL, you might be doing NoSQL. So as you can see, we have a lot of different libraries, because Spring is used in a lot of different ways. Spring is used for more than just making APIs. You can make a regular website. You can do what's called microservices, which is like each individual application kind of just has a single job, and they message each other, and you can use Kafka or RabbitMQ to do that. Okay, you could use Spring Shell, Prometheus, Wavefront. There's you have things that help you for testing and things that help you for documentation. There's so much stuff in here, all right? I don't even know all the different dependencies. I haven't used all of them. But what we're going to do are these four, so make sure you have these four selected, because that's what we're going to use to make our API. And then all you have to do is basically just hit generate, and it will download a zip file which contains your Spring application. So I'm going to go ahead and open this. What you'll notice is that inside of your zip file, there's a folder with all of your stuff in it. So you're going to want to like copy this folder or move it somewhere where we can work on it and open it up in IntelliJ. So we'll go ahead and do that. All right, took the folder and I opened it up in IntelliJ, and so now I'm going to look inside the source folder and the main, Java, etc. All right, and then we've got our Spring application, right? And you'll notice that it's like, well, Jonathan, you like had all this buildup. We had all these drivers and this and that and the other thing. This doesn't look like there's much here. Well, actually there is, just mostly behind the scenes. It's going to sync and download some dependencies. It probably will do that for you. There's a lot of dependencies it needs to download, so you'll have to be patient. So we'll wait till that's done. All right, and so we have a main. So instead of basically instead of having like a main class, you have like your application class. There's an annotation called Spring Boot application, and essentially it just has run, right? It will run the application from here. So you're like, well, where's all the stuff? Like, if you look in your POM XML, you'll find there's quite a few things in here. All right, the MySQL connector, the Spring Data JPA, all that good stuff. All right, and so, like I said, we don't want this was able to help us. If you look at external libraries, for example, there's a bunch of stuff in there. So all you gotta do to actually start up your Spring application is to hit run, and then it'll take a second, and it's going to use what's called netty. If you see this lumbuck requires you'll want to enable annotation processing. Okay, so we can use lumbuck later. Okay, and then you'll see a little bit of word art, and it will start up. It's going to fail initially because we haven't set up the database or anything like that, so we have to go ahead and do that in a future lesson. But what you should see is some word art, and then it will attempt to start the Spring Boot application. So you should see all this good stuff, and we'll go over what this all means. So if you were able to get this far, that means you're able to set up a basic Spring Boot application with Spring Boot Initializer. If you got any problems, we'll try to go over them, but it's fairly straightforward using the website. Okay, and again, it's not supposed to start yet because we haven't actually hooked up our database to our application, so it's going to try to connect and then obviously fail because there's nothing to connect to. But hopefully you're able to get this far, and then in the next lesson I'll talk to you about the database itself and what we expect there and how we're going to get it all hooked up. For this course, you'll need to download MySQL Workbench. And the reason we're using MySQL Workbench is because it will work on most computers. We're not using SQL Server. There is another version of SQL called SQL Server, but the problem with that is if you're using a Mac, then you won't be able to download or install it. So SQL Workbench will be what we'll go with. Now, it is the flavor of SQL we'll be working with. It's called MySQL. There are different flavors or kinds of SQL, different ways in which you can write SQL. To be honest with you, they're mostly the same. So there are differences, obviously. But if you learn MySQL and everything in this course, you should be able to handle pretty much any SQL that comes at you, and then you can just learn the occasional tiny difference that does pop up. All right, so we're going to go ahead and install. You want the MySQL installer. I'm using on Windows. There is also for Mac and for Ubuntu, so probably you're either a Mac or a Windows user. All right, and so you're going to be able to download and install the MySQL Workbench. The one thing I wanted to make certain that was clear from the beginning, it will ask you for a password. Okay, you're going to create a password for your user. Okay, you have to log into MySQL Workbench as a specific user. Let me show you what that looks like. Okay, so essentially when you are going to log in to your local database, meaning the database that is running on your computer, you're going to have what's called a root user, and when you install MySQL Workbench, it's going to ask you to have a password for the root user. Please, 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 write down that password somewhere where you know where it is, all right? Because trying to reset the password will basically mean you'll have to uninstall Workbench and SQL Server, and you'll have to go through a very, very arduous, long process of resetting your password. It is not like a website where you can just hit reset password and then you can easily update it. It is just not like that. So when they ask you for creating a password for your root user, you need to make certain you know that what that password is. I would go so far as to write it down just to make certain. All right, and so when you've got everything installed, you should be able to have MySQL Workbench. Okay, this is under the MySQL community downloads. That's another thing I wanted to point out is we're using the community, which basically means free, right? We're not going to actually pay for the enterprise version of MySQL. We don't really want to do that. We want to just go ahead and use the community version because that will make it easier for us, all right? And so, again, when you go ahead and you can download the installer, okay, you can go ahead and download the MSI installer if you're on Windows. You just tell it to start your download. Cool. Okay, I've already got mine installed, so it will take me to here, but again, you might want to, again, go through the whole wizard and make certain that you set the password for your root user and that you know what it is, because otherwise it's going to be very, very hard. So the installer looks like this. All right, you want the complete. Okay, and after this, you can just go ahead and install it. And so it will have everything you need for you. All right, so that's what you need to get set up for this course. Make sure you get MySQL Workbench. Make sure it's community. The community section, make sure that you know your password for your root user and that you install SQL Server. Okay, once you're all done, you should be able to come here and you should be able to see a little box that says local instance. All right, so if you don't, you might not, then you always hit the plus button. All right, and then you can leave everything as a default, right? Root 127.0.0.1 3306. Just leave that here, and maybe you can call this like local DB, okay, for the connection name, and you can hit test connection to see if it works. All right, mine says successfully made this the MySQL connection. All right, so that way you know that you actually can connect to the database. Now you may be wondering what database, Jonathan. When you install MySQL Workbench, you install a database on your computer. It is local to your computer. So that is where we're storing information, doing all of our stuff throughout the rest of the course. All right, if you have any questions, please comment, and then we can try to work through any specific systems problems you might have, but installing SQL Workbench should be fairly straightforward. All right, first things first, to get our Spring application going, we need to actually connect to the database. And so we're going to use a local database, so hopefully you are able to install MySQL Workbench. We're going to use a MySQL database in this case. If you have like SQL Server installed on your computer, you could use that, but you'll have to use a different driver, and the setup will be slightly different, which I can show later. But we're going to use the MySQL database and MySQL Workbench because that will work on most people's computers. The problem with SQL Server is that you will not, as of this video, you will not be able to use it if you're using a Mac. So, since that's the case, we're going to actually leave IntelliJ and we're going to go to MySQL Workbench. And we're going to create a new schema. You can see this like database looking thing with a plus sign. And then all we got to do is we'll call it Supermarket DB. All right, that's what I'm going to name my schema. Remember, we're going to put underscores, there's no spaces, and then all we got to do is hit apply. And then we'll hit apply again. It will do its thing. We can finish, and you should see it on the left. Now I have a bunch of databases from other videos, etc. So obviously this area is going to have more stuff than what you have. But as long as it has like Supermarket DB like this, then that's what we're looking for. All right. The other thing I want to make sure you remember is your password. All right. So remember, we're running a local instance of MySQL, meaning this is a server running on your computer in the background. So we want to make certain that you have it, like it's working, so you should be able to try to connect to it. All right, so if you can't connect to it, you need to debug that first, because if you can't connect to it, Spring Boot won't be able to connect to it either, and that will be an issue. All right, now that we've got that going, let's head back to IntelliJ, and you're going to actually go to this application.properties file here under the resources folder. And application.properties is a very, 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 very useful file in Spring Boot. It contains all the configuration, right, that you'll need for your Spring Boot application. This file is essentially like, it's like a granary, right? Like the whole, like back in the day, villages had like granaries where they would store all their grain and everyone could kind of use it. This is sort of similar. It's like a place where anything in your application can grab information from. So it will contain configuration. For example, how do I connect to the database? So let's go to there. I already have it set up, so I'll zoom in, and this will also be included with the lesson because this isn't like coding. This is just like, this is how you set up a the database connection. So for example, we've got spring.datasource.url. So on the left we have essentially like a name, and these names come from the configuration, and they're equal to certain values. So for example, what I want you to do is for the URL, you're going to put JDBC first with a colon, MySQL : // localhost 3306, and we're going to use the name of our database. So we named our database, if you remember, supermarket_db. And that's what we're going to put after here, supermarket_db. We're telling the computer, go to my local host on port 3306, which is where MySQL server should be running. So I got that port 3306 from here. Okay, so you can see it's right here, 3306. If for some reason yours is different, double check here to make sure the port is the same. And then after that, you're going to put username as root, and then you're going to put your password inside spring.datasource.password. So the cool thing about application.properties is that you don't have to put it in GitHub. In fact, I would not put it in GitHub. I would not put it any place where it is like globally visible. Eventually, you're going to actually have this in a safe location, probably encrypted, because it contains secrets. It will have passwords and things like that. We don't want that out in the open. But while we're doing this tutorial, it's just on your computer, so that should be fine. Then this is pretty much set. This sets the driver, and we're also using a thing called Hibernate. And we need to tell Hibernate what dialect of SQL we're using. We're using the MySQL 8 dialect. Honestly, you can just copy and paste this text from what I'm giving in the lesson and put your name and password and change the name of the DB. And that's it, right? This is not something you have to memorize. This is just something you have to set up once, and then you'll forget it. So after you get the password and everything in, we can test to see if whether or not it works. And we'll do it. I will do the test in a moment. Let me put my password in, and then I'll show you how to test it. Okay, so if it works, what should happen is you should just be able to run your Spring application, and there should be no errors that pop up. So I'm going to actually make this bigger. You'll see Spring come up here. It will have a bunch of stuff, right? And then it will start your Spring application. All right, so it should say started for Spring application in whatever amount of seconds, and then there should be no errors popping up. So that means that it was able to connect to your database, the password was correct, the database is running, all that good stuff. The typical things that go wrong in this section are you put the wrong password in. Double check the password. Are you sure that's the password you set for the database? A lot of times people forget what password they pick. Also make certain that, again, it's running. You may need to, if for some reason this is not running, maybe in services you have to like manually start it. There's a couple of things that could go wrong with MySQL Workbench, so you have to troubleshoot. But if everything's working, you're able to connect, you put everything properly in application.properties, you should be able to start up the Spring application and then not get any errors, and it'll just sit here waiting for people's commands. All right, so it took a little bit to get Spring set up. Honestly speaking, once you get the hang of it, it's not that bad. And from here, we can learn how to actually use Spring Boot to create our API. All right, so we worked hard to get Spring Boot like running, right? We got all the dependencies, we set up the database, but what does Spring Boot actually do? Like, why are we using Spring Boot, and how is it helping us create an API? Here's the thing, Spring Boot at the end of the day is a dependency injection container. Well, what is that? Here's the idea. You're going to have an application that does a really complicated thing like an API. Like it receives requests, it returns responses. That's going to require quite a few classes and a bit of code to get all that to run. Those classes are going to need to work together as a team, and some of those classes are going to depend on each other, right? So one class will not be able to do the job of doing the API all by itself. It will need a team of other classes to help it perform the overall function. Spring Boot allows us to keep track of classes and make certain that we can do dependency injection, allow one class to have another class be made available to it, okay, on the fly. What do you mean by that, Jonathan? Okay. First off, I have this dependency bean, and you'll notice I have this annotation above it called component, and we're going to learn more annotations as time goes on. So if you don't know what this is, don't feel you have to know what this is. You will learn what this is momentarily. I'm just having this here purely for the purpose of displaying what Spring does. I'm going to say that this is a class, and I'm going to call it dependency bean. This class has a job, some kind of job. It could be grabbing data. It could be deciding like what the proper discount to apply should be. It could be all kinds of things, right, that could be in here. But it has a job. And because it has a job, it could be used multiple places throughout our application. Maybe we have to calculate taxes when the person checks out, but then we also have to calculate taxes when it's tax time, and we have to like say, okay, here's how much we owe the government. This bean could be used in multiple different places throughout your application, and because of that, we need something, right, that will keep track of saying this thing exists and other things need it, and if they need it, I will give it to them. To make that point even clearer, let's say I have another class, right? Also, that's a component. And notice that I have it as a property. This is a has a relationship, okay? This is my bean, all right? And these are called Java beans. We'll get into what Java beans are a little bit later. But you can just think of Java beans as essentially like things you can inject, all right, at the end of the day. So my bean has a dependency. It requires the dependency bean to do its job. So I'm going to give it the dependency bean. Notice how I'm not doing like, I'm not instantiating it. I'm not doing dependency bean 1 equals new dependency. I'm not doing this. I'm not instantiating. I'm not doing any of that. What is happening is through the use of annotations, okay, like auto-wired, for example, Spring is basically saying, hey, you need this dependency bean, right? Well, you've marked it with this component annotation, and I know how to get it. I know how to construct it. I know what to do with this. So if you need it, here you go, bro. I'm going to give you a copy. That's what dependency injection containers do. They hold all the different things, all the different classes and objects that could be used in various places around the application, and if anybody needs one, they can get one. All we have to do is learn how to use the annotations properly and how Spring Boot does its job, and then that's it. We just basically let Spring Boot do the dependency injection for us and orchestrate all of our classes. To bring this home, I'm going to go ahead and run this and show you what happens. I'm just going to run the application. I haven't accepted any requests. There's no responses. I am literally just running the application. Okay, so notice, again, we have all the text, yada, yada, yada. But notice I've got these two little lines here. My bean is initialized and dependency bean is injected. So where did that come from? Well, in here, in my bean, right, I've got an init function that says, cool, my bean is initialized. So this init function, right, was run here. It must have been, otherwise we wouldn't be seeing this message. But like, how did that happen automatically? I didn't write, as you notice, there's no code here. I didn't write any of this. I just hit the play button and then it started. So what Spring does, right, is it knows, because I put this annotation on this class, it knows this class exists, and I can tell Spring what to do at different points. So for example, I had it do post construct, which basically means after it's created. So it will run this and you'll see it. Then in dependency bean, all right, you'll see dependency bean is injected, right? See where I put that here. Okay, print dependency. Where did this come from? Well, I had it print the dependency, right? So when this my bean was initialized and first came into being, Spring Boot said, cool, you need this dependency bean. It is a dependency. So you have auto-wired, so I'm going to give you a copy. Cool, you got a copy. And then I took the copy and I just had print dependency. Spring instantiated everything I needed as I told it, and then made certain that any hazard relationships were all fulfilled. And as you can see, it did that automatically. I didn't have to actually code anything. So Spring Boot is going to keep track of all of my different beans throughout my entire application, and all I have to do is learn all the annotations and what they do and why you use them. Okay, after that, building things like a website or an API become actually pretty simple, because as long as we follow the way Spring Boot expects us to annotate things or to organize things, then we're able to very quickly get things up and running. And that's the idea. We want to be efficient. We want to be able to get our application out as soon as possible. And so the less rote stuff we have to do, the better. And so if we can load off some of the work on Spring Boot, then we will. If you did not completely 100% understand this lecture, that's perfectly fine. I want to just reiterate. Dependency injection is hard to understand at the very beginning because a lot of it's magic, right? It's happening behind the scenes. You don't see it. I tell you what to do. You do it. It worked, but you don't really know why. It will take some time to appreciate why this is so cool, like why it is that this is very, very convenient, all right? But the only thing I need you to really understand at the end of the day is that these annotations tell Spring Boot what this code does in light of the whole program, and Spring Boot will look at the annotations for you and do the appropriate actions for you. That's why we're using Spring Boot. Okay, as long as you understand the annotations basically say, this is a component, this is a service, this is a controller, and by doing that, we basically say, here is how you deal with the class Spring Boot. This is what it is. Here's how you deal with it. If you get that part, if that part is something you can understand by the end of the course, then it's a success. Okay, some of the finer points you may be a little bit hazy on, but it will just take some time, all right, to get to understand this. Be patient with yourself. All right, we've got Spring Boot set up. We have some idea of what Spring Boot actually does. Let's start building our API. All right, another thing we're going to need is Postman. All right, Postman is a application that allows us to very conveniently call APIs, and we'll use it mainly for testing. But I also want to take the opportunity to talk to you about what APIs are in case you're like you're new to this. So again, I am assuming you have some basic Java skill. If you do not know much about Java, then you will need to go. I have a course that does all the basics, so you can get up to speed on that. But you may know Java, but you may not really know what an API actually is, or you've heard the term before, you have some feeling, but you've never actually gone into it in more detail. All right, so first off, let's make sure we have Postman. I'm at postman.com/downloads, and you can download it when there's a Windows version. And you do have to sign up, but it is free, so nothing we're doing requires a paid version of anything. So go ahead and download and sign up for it, and then once you're done, you should have Postman open, and there may be some other stuff, but I'll just clear everything out and make it blank. All right, so what is Postman? Postman allows us to very easily call APIs. You could do this through the command line, but this is a GUI and it's just more convenient to use. Now in the future, I'm going to be, again, in the course, I'm going to be using Postman. If you really don't like Postman, there's Insomnia. There's also there's a lot of other clones of Postman that do exactly the same thing. Or you can use curl. I don't really care which one you actually use. I'm just going to use Postman for the sake of the course because it's very easy to use and it's very easy to see what's going on. So now let's talk about APIs. So the internet is filled with information, and we want that information, right? So we need information to show websites. So for example, I have here a website called Hoobly, which is where you go if you're looking to it's like Craigslist, you buy stuff. And let's say I want to purchase a puppy. Okay, I want to get a puppy. This website actually has a lot of stuff going on. It has text and images and all sorts of things. So I'm going to kind of show you something. I'm going to hit F12. I'm using Firefox. F12 should work for Firefox or Chrome. It'll bring up a little console. Now mine's at the bottom. Yours may be at the right. It doesn't really matter. It's the same thing. So I'm going to hit Network. There should be a Network tab. And when I have it open, I'm going to reload this page while the Network tab is open. I want you to kind of see some stuff. It should fill up pretty quickly. And each one of these lines is a request. All right. Well, what is it requesting, Jonathan? In order to run this web page, right, it requests data from a server. The server is sitting somewhere, God knows where. It could be someone's closet. It could be in the cloud. I'm not sure. Probably in the cloud. And you'll notice that each request, right, this page actually makes lots of requests. Bootstrap, jQuery is downloading libraries from the internet. It's downloading photos of the puppies to show us. It's probably downloading some security type things. There's a bunch of stuff, fonts it could possibly be downloading. Each one of these lines is a request. Hey, I want you to go out on the internet and go to a certain URL. Okay, so Hoobly.com. GoogleTagManager.com, Pixelhoobly.com. Go somewhere on the internet, and I would like to get some information, or I'd like to send information. There are different parts to a request, and we'll break this down a little bit more, but for right now, I kind of want you to know the basics. The requests will have a method attached to them, all right? Actually, let me close this back. Oops, let's go back. There we go. Let me make this wider. We'll see this in a second. Each request has a verb along with it. Remember, a request is being sent out over the internet. When the person receives the request, they don't know who they got it from. They don't know you. You're just a random stranger from the internet. So how do they know what you want? You're sending them this random request across the internet, and they're like, well, what do you want from me? The verb here, the method, tells the person receiving the request, hey, this is what I want from you. We have get, for example, which is probably the most popular one, which means, hey, I want you to give me information, Mr. Server. Here's a request, and I would like to get information from you. Probably these pictures here, right, are all get requests. That way we can get the picture from the server so we can put them on the page and let the person see the puppy that they would like to purchase. There's some other requests here. I don't know all of what they do, but the verb is important because the verb lets the server know, hey, the person making this request wants this from you. we're going to get more into other parts of the request later on. The request is actually a multi-part piece of information. It has a method, it has an endpoint, right, where it's going. It could be a request for files, it could have headers and body and all this good stuff. I'm not going to try to overload you in the beginning. I just want you to know right now, a request is essentially a packet you're sending to a server sitting somewhere that receives the request. It will look at the verb, okay, the method, to say, what do you want from the server? Do you want information? You want me to send you information? What do you want me to do? It will then give us a response, okay? And the server will say, okay, cool, I've got your request, and here's a response. All right, and sometimes there is no like data in the response, and sometimes there is, but that's essentially the way that this works. I, the client, the person who wants to use the API, is sending a request. I am going to send you all the information you need, Mr. Server, to process my request. You will process my request, and hopefully you'll give me a response and everything goes well. Let's practice actually using an API. So let's go to Postman, and we're going to just do like a little like whimsical API for dad jokes. Okay, so hopefully you've got Postman set up, and we're just going to practice using an API before we actually get started with building it in the next lesson, all right? So make sure you got Postman installed. Again, that was just a quick, very brief rundown on what a request is. All right, so hopefully you got a feeling for it. In the next video, we're actually going to make a request to an actual API so that we understand kind of what we expect. Like, what are we actually building? Because we're going to build an API, but if you don't really have a feeling for what that actually does, then you're going to be very, very confused throughout the whole thing. So let's actually practice using APIs first, and then once we do that, we'll get into actually building our own. All right, so let's actually practice using an API. And I'm going to go to ICANN has dad joke, which is a dad joke generation API. So if you need a dad joke on the fly, they've got you. All right, so this is usually APIs have documentation telling you how to use the API, because essentially like APIs can be built all different kinds of ways. So you need some sort of documentation to tell you like what you're supposed to actually like do in order to use the API. You don't just psychically know how to do things. All right, so we're basically looking for what's called the base URL, and so here we have the endpoint section. So this is basically like, you can think of an API as having points that someone can come to actually do stuff. They're called endpoints. So what do you mean by that, Jonathan? So for example, I would like to fetch a random dad joke. If I would like to fetch a random dad joke, see how they give you the HTTP verb here, and they give you what's called an endpoint. This is where you go on the internet if you would like a random dad joke. So how do we actually get the random dad joke? How do we make the request to the ICANN has dad joke API to get back our information? Well, first we're going to need to copy this endpoint right here, icanhasdadjoke.com HTTPS. Let's go to Postman, and we're going to hit this plus sign to make a new request. Now notice we have the verb here. So let's go over the verbs. There is, the ones you care about are get, post, put, patch, delete. We'll go into way more detail about what each one does as we build our API, but at the end of the day, these verbs tell the server that we're sending the request to, hey, I'm making a request and I'm a stranger and you have no idea what I want. But if you look at the verb, you will know what I want. So for example, we would like to get a dad joke from the server. Give us a random dad joke. Well, that's going to be the get, okay, verb. You should memorize these verbs. Get, post, put, patch, delete. It is vital to building and using APIs so you understand what these verbs do. Again, we're not going to go into an exhaustive, detailed explanation right now. We're just going to try to use an API for the first time. We're going to make sure we do a get, and we're going to put our endpoint here, icanhasdadjoke.com. Now remember when I said that requests have multiple parts to them. It's not just the endpoint and the verb. As you can see in Postman, we actually have the ability to manipulate different parts of the request as need be. One thing I want to make excruciatingly clear from the beginning, not all requests have the same parts. There are different parts of the request that you can pick from, but it does not mean everything has to be included. For example, requests have headers. That does not necessarily mean that you have to have a header for your request, right? That it just basically means that headers are part of requests, as normal, right? But you don't have to have them. Your request could have a body. It could have one, it doesn't have to have one. So we sort of like pick from the different parts of the request that we want to add stuff to, depending on like what requests we're making. So for this one, iCanHasDadJoke.com, they would like us to let them know how we get the information back from them. And what we're going to do is we're going to let them know what we want, what's called JSON format. When they give us back information, when we get the response, we would like the response to be in JSON. So click on headers, and they have key value pairs for headers. The key is going to be accept. Notice how as you type accept, it pops up. That's because certain keys are commonly used, right? Accept is a very commonly used key. So what we're saying is, hey, when you give us back the response, what we accept is JSON. Start typing in application/JSON, you'll see it pop up. Okay, so that's just one of the things you can get back as a request. Well, what's JSON, Jonathan? Well, actually, let's just do the request and I'll show you. Hit send, and bam, we get a random joke. This down here is called JSON. It is a type of way to format, right, information. If you are familiar with JavaScript, right, this should look very familiar to you because it's a JavaScript object. If you're not familiar with JavaScript, that's fine. You don't have to be. All you need to know is that this is a packet of information and it has key value pairs. This is the key, this is the value. So that means that the ID of this joke is this. The joke itself is, what do you call a magician who's lost their magic? Ian. Okay, status 200. We'll get into what the statuses mean as we do the API, but the main thing to understand is that this response is also a big bundle of information. So it has all the information about the joke in JSON format. It has a status code which tells us, hey, here's what happened with your request. Because remember, like, we're sending the request to an absolute stranger on the internet. I don't know what happened with the request. I threw it into the internet, and then I need to know what happened with it. The status code lets you know what happened with the request. 200 OK means everything went hunky-dory. We received the request, we processed it, we handed you back a response, there is no problems. This is an API, guys. An API is endpoints, right? And you have multiple different endpoints in your API that do different things. You'll pick a verb. You will craft the request and add headers as need be. You'll add stuff to the body as need be. You may even need to log in to the API because only certain people are able to access it. You can include parameters. All this stuff I'll teach you how to do, right? But at the end of the day, you build your request based on what you want. You will send the request to an endpoint. The server will receive the request and process it and give you back a response along with a code telling you what happened with your request. That is what an API is in a nutshell. Everything else is just details of how it receives requests and how it returns back responses. All right, so hopefully you got that. All right, so practice a few times. Also, there are other endpoints to this API. Well, Jonathan, like, is there like a standard number of endpoints per APIs? No. APIs are however the person builds them. So for example, can you tell just from the request and the response what language this API was written in? No. Maybe they used Spring Boot. Maybe they didn't. Maybe they just did like their own, like, you know, server in Rust. I have absolutely no idea what language they wrote their API in. And the cool thing is I don't need to care. That's up to them. They can do that sort of stuff. So as far as what the API can do, that is based on the person who wrote the API. Just like when you build your API, you decide what the client can actually do with the API. So for example, if we go back to the documentation, we can look at the endpoints and see all the different things we can do. So for example, we can fetch a random dad joke, we can fetch a random dad joke as a Slack message, we can fetch a specific dad joke by its ID. So notice how this is a little bit different. Okay, it has iCanHasDadJoke.com/J/joke ID. What does that mean? So that means if I type in /J/ and I put this ID here, I'm going to copy this ID without the quotes and put it at the end. This is a different endpoint. This endpoint will give me back different information than the endpoint we just used. So by changing the URL, I can change what kind of information I would like to get. So let's try this. Here we get that specific joke, all right? So notice how if I just do the regular endpoint, I'll get a random joke. Where do fish keep their money? In the riverbank. That's terrible. If I do /J/ and an ID, I don't get a random joke. I get a specific joke by its ID. So as you can see, different endpoints give back different information. So part of building an API is figuring out what endpoints do you want to have open for the internet to use. Okay, because these endpoints will give people access to information or allow them to send you information. Now, there is a lot of intricacies to APIs as far as request and response, but as long as you understand that the request has multiple parts, many of which are optional, you have an endpoint, which is where in the address on the internet where the API endpoint is. You have a verb that is basically there to say, hey, this is what I want from you, Mr. Server. And you understand that you'll get a response back from the server with the code and some information. As long as you understand that, you should be good enough to start building an API and starting to eventually gradually understand, okay, what they do. All right, now that we've got some practice with an API, let's actually start building our own. All right, so the cool thing is, as we go through, we will not have to really touch anything in our main application right here. This part, you don't have to touch anything. You just basically leave it alone. We're going to be writing everything else in other places. So let's actually set up a folder structure that we're going to use, all right? And so what I mean by that is we're going to make packages. So in IntelliJ, again, I'm assuming that you have some Java background. Okay, so one thing I want to kind of say before we begin is that you should have some Java background. So you're not, if you don't know the basis of Java, you're not really going to have a very easy time writing an API in Java. So if you need a refresher on Java or feel that you don't have the skill for it, I do have a course that just goes over the basics of Java. You can go take that and come back here. All right, let's make some packages. Do new package, and I want to call my first package controllers. So a Spring Boot application is going to have many layers, right? There's a presentation on end layer architecture in this unit, and so you should take a look at that. But the idea is that each layer has its own responsibility. We try not to blend the responsibility of different parts of the application into one class because that makes it very difficult to maintain overall. So we want to have classes that sort of have a very, very focused job. They do they do a couple things, or they do the one thing and then that's it. They don't do much more than that. All right, so we made our controllers package, and now let's actually make our first controller. We're going to keep things nice and simple, something to make everything nice and testable. Okay, so in the controllers, we're just going to go ahead and add a class, and let's just call this hello controller. Okay, again, we're not going to keep this long term. I just want to use this to kind of give you an idea of what you'll be building. Okay, so far this is just a regular public class, and we just call it hello controller. Now, what's a controller? A controller is essentially the thing that's going to be receiving the request from the user. An API is essentially a thing that sits there. It will sit on a server somewhere, maybe in someone's closet, maybe in the cloud. I'm not sure where. It could go a lot of places. And the program's going to run, and it's going to wait until someone sends us a request. Who will that person be? I have no idea. It's the internet. Who knows, right? It could be a person. It could be a bot. It could be anything, right? People send requests over the internet all the time. All right, so hopefully you were able to look at the slide deck about what an API actually does overall. All right, and then we also have a little lesson before this to kind of help you understand the basic idea. So that should be clear to you so far, at least clear enough to get things going. All right, so first off, remember we need to use annotations to have Spring Boot let the computer know, let the program know, hey, what is this class? What is its job? What does it do? Why is it here? We're going to put @rest controller, okay, on top of the hello controller. This is called an annotation, and Spring Boot has a lot of different annotations. And again, you could think of I think of annotations kind of like categorizing different classes, right? Hey, this is hello controller. Well, what is it? It's a REST controller. And so by putting this here, we actually give this class superpowers. Behind the scenes, and again, Spring Boot does a lot of things invisibly that we don't see, but it allows this class to receive requests and return responses. All right, so it'll be able to receive a request from the internet, and then we can let it have, return a response, and then if everything goes successful. We also can control what the endpoint is going to be. So if you remember, endpoints are like little mailboxes in our API, where essentially people can request certain kinds of information or send us information, update information. There's different things they can do with the request, and we have to sort of tell them what do they type in the URL to actually get their request. I would like everything in the hello controller to begin with /API. It could be /API, then whatever else after it, but I wanted to have /API so that people know that they're specifically dealing with an API. So we're going to do @request mapping string /API. All right, and that's it. So again, what comes before the /API, it depends on where your API is being hosted. We're going to do localhost. Okay, so if you look in Spring, it actually kind of tells you when you start it up, like where it's going to be. It's going to be on port 8080, localhost port 8080 when we start running this, but we'll get to that when we get to it. All right, and we're going to keep this nice and simple. So if you remember from the talk about the lessons about requests and responses, that we had different HTTP verbs. Okay, and the verbs, the point of the verbs is to say, hey, like, what is the point of this request? Remember, the client, the person sending the request is a complete stranger. I have no idea who they are. So what do they want from me? The verb tells me. We're going to use a get request. Okay, remember that the person wants information from us. It is very easy in the Spring Boot to handle different kinds of requests because, well, we know what the verbs are, and so we have annotations for them. At get mapping, parentheses, and we're going to say that this is /hello. So after that, we just put a method. Public, I'll just do string hello, return, and we'll just do a string hello there. Okay. This is the simplest API ever, right? It literally just says, if you go to, again, the address will be localhost port 8080 /API/hello. So you see how this is going to be prepended to all of the different endpoints inside the controller. And then when we use get mapping, I'm also saying that this specific endpoint is going to be /hello, so we'll combine them to get the full URL. And this is what someone will have to put into the browser or the Postman or whatever they want in order to use our API. That's it. This was really simple. Okay, what you're going to be doing for Spring Boot is we're going to be learning all the different annotations, right, that you can use, what they do, and how to customize them. After that, you just basically use this like Lego blocks. You just figure out what endpoints you want to have, what data you want to return, annotate things the way they're supposed to, put them in a certain position or order, and then the API will run. So let's test this out. I'm going to run my API. I'm going to hit the play button and then wait for it to start up. I'll even make this a little bit bigger so we can see. I'll wait for it to start up. There we go. Blah, blah, blah. All right, starting service Tomcat, etc. And we're looking for this started first application in blah, blah, blah seconds. Okay, that means that, nothing wrong happened, everything's good to go. Let's test our API. What we can do is we can use Postman. So hopefully you already have Postman already installed on your computer. All right, I've opened up Postman. It's blank. There's nothing here. Let's go ahead and hit this plus sign to make a new request. All right, so we're going to do a get request. All right, so it's default, gets the default. So we'll do HTTP :/localhost port 8080. Remember, this colon means port. /API/hello. Right? This is the full URL. This is the base URL. Okay, where the API lives, and this is the specific endpoint that I want to consume. I want to basically go here and get some information. So let's try it out. Okay, says 200 OK, and it says hello there. So there we go. We made our first API request. Notice how all we did from the Postman perspective, we put in the URL, it did the correct endpoint, and then on the Spring side, it knew to come here to the hello controller, right, and to run this method. That's the other thing that Spring is doing for us, specifically the Spring Web library, right, is able to figure out, hey, if someone types this in to Postman or wherever, it doesn't have to be Postman, could be the internet, could be whatever. If someone comes to this endpoint, where in the program do I go to run code in response to someone going to this endpoint? That is what one of the things that Spring Web does. We don't have to worry about that as long as we figure out where the request mappings are going to be. That's up to us, and write the code properly. After that point, it's pretty smooth. Spring Boot will handle taking in the request and dealing with the response for us, and that's really nice. So now that we've got, hopefully you're able to do this. Always make certain that when we do code, like type it out and try it. It is extremely important that you don't just watch me do things, that you try to do them yourself so that you kind of get a feel for what's happening. Because I can explain things all day long, like what a request and a response and etc. is, but until you do it, you don't really get a feel for it. So make sure that you are, if you have dual screens, put this on one screen and then you can try this on your own. And that way you can use Postman and figure out how this all works. Now, this is the simplest way we could possibly do things. So what we're going to do next is we're going to start working on our actual application. and build out our different layers, right? Because we're not going to just have controllers doing stuff. But for right now, we'll start with the controller and then we'll work our way down. Our first major project is going to be getting the book API going, where people will be able to do CRUD functions with books. Remember, if you don't know, CRUD function stands for create, read, update, delete. They are the basic functions that you need in most APIs, unless you're doing something very custom. All right, so this is our hello controller, so we don't really need this anymore. We'll just leave it for right now. And remember that we have n-tier architecture, so that we have different parts of our application that will work together in order to do the API, right? So it's a team effort. So let's add some packages and get some organization going. So I'm going to make a services package, and I'm also going to make a repository package. Repositories. I'm also going to make a models package. All right. So what this is going to do is it's going to help us keep track of all the different files that we will have in our Spring Boot application. And then we'll be able to look at the package and tell which one's which. So normally when you make an API, you can kind of go in whatever direction you want. You can start working on layers. Typically, I start working at the lowest layer, which is the models. And the models are essentially Java classes that represent the data in the database. All right, so we're going to actually have book information that's going to be located in the actual SQL database. And so the lowest level of this entire application will be the model, which represents the table, the book table, and then all the books within the table. So what you do is you first create a class. So we're going to create a book class. All right, so this represents a single book. It is important when naming classes that when you name the model that it's singular, because the table will be multiple books, all right, but the class itself represents a single book. Now, let's go through and figure out what properties a book should have. So I think a book should have an ID, which will serve as the primary key. All right, so you don't have to be an expert in SQL to do this course. The idea is that actually the Spring Data JPA is going to handle SQL for us. However, if you are a little bit rusty on SQL or want to know more about it to feel more comfortable, then I do have a course on SQL which takes about 5 or 6 hours, and that should actually half of it should get you up to speed with what you need for here. All right, so we'll have the ID be the primary key, which is the identifier for a book. So each book will have its own unique ID. A book will have a title, right? A book will have an author. A book will have an ISBN. And then we'll also have a Boolean to say whether or not the book is available, right? So, for example, we should be able to lend out books to people, and it will be important for us to figure out whether or not the book is available. Now, on the normal circumstances, what you would do from here is you would use if you're using IntelliJ, you can generate the constructor, right? So you actually can just right-click generate and then create a constructor in getters and setters. But earlier, when we actually set up the dependencies for Spring Boot, we downloaded a thing called Lombok, which you probably saw in the lower right. It asked you to do enable annotation processing, which I hope you hit yes. So what does Lombok do? Lombok allows us to reduce boilerplate code, well, by a lot. Watch what happens. All right, so first off, we have this class called book, and this class represents a table in the database. So I'm going to actually mark that's what this thing is. If you remember the Spring Boot, the strategy that we're going to use is we're going to use annotations to mark classes and let Spring Boot know, hey, this is the job this class serves within the application. This is an entity, so I'm going to do @entity, all right, and you'll see it as Java. What I want is actually JavaX. JavaX.persistence. Actually, no, Jakarta. Actually, no, it is Jakarta. All right, so it got updated to Jakarta. So Jakarta.persistence.entity. Awesome. All right, so this @entity annotation is basically saying, hey, this book class represents a table in the database. It's an entity. It's a representation of data at rest in the persistence layer. Now let's use Lombok. Lombok is going to allow us to basically not have to write constructors, getters, and setters. I'm going to say that this is data. Okay, notice that comes from in Lombok.data. I'm going to add a noargs constructor, and I'm going to add an allargs constructor. Well, what does this do, Jonathan? Well, this will give the class a noargs constructor, this will give the class an allargs constructor, and this will do all the getters and setters for the class. We literally do not have to write anything else for this class. Okay, data also handles the string and then the equals and hash code methods as well. So this really saves you a lot of typing, because after I put these annotations down, we're done. Okay, we have a book entity. That's it. We just have to basically enumerate what the properties are going to be, and we just kind of go from. Now we do need to add one more annotation. Well, actually two more. I do want to indicate that this ID here is the actual primary key of the book entity. So I'm going to put at ID. Right? And that's going to be like, hey, this is the primary key. I also want to tell Jakarta, basically Spring Data JPA, like, hey, when you create a new record, I want you to auto increment the ID. All right, so I want auto increment on. So what we can do is add generated value. Strategy is equal to generation type dot identity. All right. So what that will do is that will put auto increment on for the ID. That way we don't have to worry about setting the ID for every new book that goes into the SQL table. All right, perfect. So let's take a look and see what happens. Let's actually run our Spring Boot application, and then we're going to take a look at something. So we'll get, all right, here we go. Yada, yada, yada. All right, cool. So now we got it started, and it didn't like blow up on us. All right, so let's go take a look at the database. So I'm going to go to the MySQL Workbench, connect to my local instance, and I believe we named our supermarket DB. All right, and I'm going to see there's tables. Yeah, there's a book table. All right, so right here, and then let's go take a look inside of it. All right, and you'll notice that, well, we didn't make this table. Okay, awesome. So it has an ID, author is available, ISBN, and title. Now, the only thing is I don't like it being called book. I tend to like plural names for my table names, but that's okay. So if we go back, I'm going to cut this off. And what we can do is we can add another annotation to basically say, hey, this is what we want to name our table. So we're going to do at table, shocking no one. And then we're going to do name is equal to books. Okay, we will have to import this annotation, no problem. Okay, awesome. So this way we can actually change the default name. So it will go with the class name by default, and then if you change it, well, we'll do what you want it to be changed to. So let's go take a look. I'm going to restart the application. All right, let me make it go bigger. Okay, it does take a little while to get started, but that's all right. Okay, and then we were looking for this started. Okay, right here, and then let's go take a look inside our database. I'm going to go ahead and refresh this. Okay, and notice there's a books table. Now, it doesn't get rid of the old tables. I just wanted to, I did this partly so that you could see that. You'll have to just drop the table manually yourself, but notice how it does make a books table for us, right? And again, it has all the same properties of the class. I'm going to get rid of some of this stuff. What I mean by that is if I do select all rows, you'll see it has an ID, an author, and is available, ISBN, and title, just like we put in the entity itself. All right, so as you can see, this saves so much time. It used to be you had to actually write a bunch of stored procedures to create all the tables in your database and all that good stuff. But now you can just use Spring Data JPA, and there we go. Like, it will just create the tables for you, and Lumbuk can keep us from having to write a bunch of boilerplate code, so creating an entity is actually really quick. So we have the entity, and this represents a table in SQL, and we've laid out all the columns and said that this is the primary key and all that good stuff. But the entity itself doesn't actually do any of the functionality as far as like getting all the books or updating a book or deleting a book or any of those things. The entity is just there to store data and represent the table. That's it. We need a class that's going to actually handle all of the data procedures, so like working with books and getting that sort of data. That is going to be the repository. The repository is the class that is responsible for handling all data. That's what it does. It does a very, very simple job. Now, the key thing here to remember is a repository is very straightforward. It just gets data, deletes data, updates data, all that sort of stuff. Okay, so if you want to like find all books by a title or find a book by its ISBN, then the repository is the place where you go where you have that functionality. All right? It does not handle business logic. So, for example, things like figuring out late fees for a book. Someone turns the book in late, they incur a late fee. How much should they have to pay for the late fee? The repository is not responsible for figuring that kind of thing out. So we're going to make a repository, and actually it's going to be very simple. You'll be shocked at how simple this is. We're going to make an interface instead of a class. All right, we're going to call it book repository. Okay, remember it's an interface, not a class. And what we're going to do is we're going to have this interface inherit from another interface. We're going to have it extends JPA repository book, comma, long. Right. This should we're at the import book because it won't know what that is off the bat. And what if I told you we're done? Like, as far as CRUD functionality is concerned, we're done. We don't have to write anything further. Why? This JPA repository is built in, and it comes with a bunch of methods that we get for free. We do not have to write them. Now, I say CRUD, remember, CRUD stands for create, read, update, delete. So, for example, get all books is a CRUD function. Get book by ID is a CRUD function. Create book, delete book, update book. These are common functions that you have to write when you make entities in your table, because you're, like, you know, saying we're at the manager of books, right? Our library could have books coming in. We could be discontinuing books. We might need to get a list of all books. So these are just basic functions, right, that follow a specific pattern. People call them CRUD functions because, well, they come up all the time. A lot of junior devs, for example, will have to write CRUD functions because that's just a simple thing junior devs can do. Now, this part here is important. After you do JPA repository, you have a generic, and the first type is what entity is it keeping track of, and then the second part is what is the type of its primary key. If we go back to book, the primary key is this ID, and it's a long, and that's where we get this from. Okay, that's why this is here. So what entity are you working with, and then what is the type of its primary key. After that, I literally do not have to write any of these functions. Now, if I want to do find book by title, for example, or find book by ISBN number, that's going to be something that I'm going to have to put into this interface. But you may be thinking to yourself, well, this is an interface. We can't like write logic in an interface. We have to just write method signatures. Like, how's that going to work? Later on, when we add more complication to our API, when we make it a little bit more, fancier, we're going to come back and we're going to spiff up this book repository. But for right now, we literally do not have to do anything. We have all the CRUD functionality out of the box ready to go. So now we've got the repository. In the next video, we're going to go over the service. All right, the service layer is above the repository layer, and it's responsible for business logic. So the repository grabs the data, hands it off to the service, and the service will do things like calculate how much you have to pay in library fees and all that good stuff. All right, so hopefully you've got your book repository interface going. Let's move on to the service in the next video. All right, now that we've got the repository done, I know you probably don't believe that because there's nothing in it. Let's go ahead and make the service. So we'll go to services. New class, we'll call it book service. It's just a regular class. And what we'll do is we'll annotate the book service with the @service annotation. All right, so as you remember, Spring Boot wants us to annotate our classes and properties and let Spring Boot know, hey, like this is what this class is with respect to the entire application. This is a service, right? So it is a thing that is going to be injectable. So it's really nice to be able to annotate these things because it's clear what things are, and well, Spring Boot will keep track of everything for us, so why not? Now, the book service will talk to the repository. So remember that the layers talk to the layer above and the layer below. They never skip. So the book service will never have direct contact with the book entity, meaning that the book service is never going to directly talk to the database and do any sort of operation with the book. It will always be through the repository. Now, the book service, when we first write it, it will seem redundant. I just want to kind of warn you from the beginning. We're not adding business logic to the book service from the beginning. We're going to eventually add business logic, but the service is typically where that sort of thing lives. And what do I mean by business logic? It's things like, for example, finding out late fees, keeping, maybe like there is something to do with book inventory. Any sort of logic is more complicated than just grabbing the books from the database. And so that's something we call business logic. It actually is like the rules for how the business operates. Because remember, software is used by businesses and organizations to solve problems. And so what problems are they solving and what special rules do they have to solve those problems? That kind of stuff is going to live in the book service. Now, since the book service talks to the book repository, it will have a dependency. There's going to be a HAZA relationship between the book service and the repository. And so Spring Boot makes this extremely easy. So we don't really need to do too much because it's like, well, okay, if the book service needs the repository, how is the book service going to get it? We're going to learn auto-wired. Okay, auto-wired is an annotation that's part of Spring Boot that says, hey, like, I want to put this on top of a property, and I would like for you to just give me a copy when I need it. So we're going to do private book repository, book repository. That's it. That's all you have to do. So Spring Boot will basically just say, here you go. When the book service requires a book repository, I'll make you a fresh one, and then you can just go from there. It's just that easy. You don't need to do anything else more for dependency injection. So after this, we can just go ahead and write our methods. And again, it's going to be CRUD functions at the beginning. We will add some more business logic type things, but I just wanted to have all the different layers so you could see them talking to one another. Public list of book, and we'll call this get all books. So remember, we're going to do CRUD functions first. CRUD stands for create, read, update, delete. Create, read, update, delete, in case you didn't know. Now we'll have to import book because it has no idea what that is. It's nice to give it a second because it doesn't necessarily like find the entity immediately. It takes IntelliJ a second. In the meantime, while it's going, we actually can go ahead and do return. There we go. All right. Import class. Import the book. We'll have to import list as well. No problem. All right. Awesome. We're going to return book repository dot. Well, wait a second, Jonathan. Where did this come from? We have this find all method. I didn't write a find all method in the book repository. That's not here. Well, it is in the JPA repository in this interface. So by extending this interface, we get all of these methods for free. So for example, find all will give you all the books. That's it. See how I didn't have to like write this method. I didn't have to do it. I didn't have to write the method. I didn't have to do any of the implementation. I can just use it. That's how fast this is. All right, now we're gonna get a book by its ID. Public, optional, book, get book by ID. And we're gonna require the ID of the book that the person's looking for. We're doing optional, and optional makes sense here because when you look for the book, there's no guarantee that there is a book by the ID in the database. So the book could be a book or it could return null. Optional is a great way of saying, hey, like you could get a book or you could get null. So you need to make certain that you are handling both cases. So we're going to do return book repository, and yes, there's a find by ID. Find by ID, and then we'll put an ID. And here's the cool thing: if you hover over it, it knows that it takes in a long, right? So like when I did this, because I'm going to type it one more time so you can see it. It like knew the data type. See here, long ID. So that's because the interface that we made, right? Oops, let me go back to it. Interface that we made, we said the primary key was long. So therefore, it's going to be consistent the whole way through. Next, we need to create a book. We'll do public. It will return the book we created. Create book. Pass the book in. And we'll go ahead and save the book. Book repository. Repository, thank you, .save book. See how fast this is because we don't have to do all that boilerplate nonsense. The repository just makes the CRUD functions for us. All right, and then we'll do delete book. That's pretty easy. Public void delete book long ID, and then we will do book. So we're going to look for the book first because we only can delete books that exist. So we have to find the book by its ID, which we have, and then we're going to use it's an optional. And we're going to use part of the optional API and say or else throw. So basically, like, hey, we didn't find the book that you wanted to delete. We're going to have an exception. So we're going to do a lambda, and we're going to do a new resource not found exception. Resource not found exception. Okay, now you'll notice that it doesn't. That actually this is not like a real class. I'm just like showing you what you would do, like if you want to do like a special exception. Okay, we don't have one. We'll have to make one when we like spruce up our API. We'll have to make a resource not found. Okay, so let's go ahead and then do new no such element exception. All right, so book by that ID was not found. Okay, so we'll let them know like, hey, like you wanted to delete a book, but we couldn't find the book you wanted to delete. And then if we did find the book, we'll do the repository and then just do delete, which surprises nobody, and pass the book in to delete, and it will delete it from the database. All right, probably the one that has the most coding is the update. All right, so public book update book. We'll have the ID of the book we wish to update, and then the actual details of the book we wish to update. Now, the thing with update is sometimes you want to allow people to only update certain things about the book, and maybe like you want to restrict it, but we're just going to go ahead and allow people to update pretty much anything about the book except its ID. So first, if we'd like to, this is very similar to delete, right? We can't update a book that doesn't exist in our database. So we have to go look for it first. Book repository, find by ID. So we're going to go find the book by its ID. If the book is not there, then we're going to throw an exception. We're going to do a new no such element exception, book by that ID was not found. So let the client know, hey, I didn't find a book to update. All right, once we do, all we have to do from here is say, okay, cool. We're going to set the title of the book to the incoming title. So book details.getTitle. And we're going to do the same thing for author ISBN is available. So set author, book details.getAuthor, book.set ISBN. This is a little bit boring, I know. We're just going through, but this is necessary because, like I said, you may or may not want to allow the person to, do all these things. So you get to kind of choose what gets updated here. Again, it makes sense for us to allow the user to update the title, author, ISBN, or whether or not it's available. And then after that, we're going to just go ahead and save the book and return it. So what this will do is it will return the book that was saved, so that way that the client can take the updated book and do what they want with it. All right, let me make some room here. And as you can see, that using the JPA repository saves us so much time because these CRUD functions, right, we did not have to write any of them. All right, so again, get all books, book repository.find all. Get book by ID, book repository.find by ID. Create book, book repository.save. Delete book. We search for the book first to see if it actually exists in the database. We threw an exception if we don't find it. If we did find it, we're going to delete the book. Update, we search for the book that we want to update. If we don't find it, we throw an exception. Then I update the properties of the book based on what I want to allow. I'm allowing the person to update the title, the author, the ISBN, and whether or not the book is available. Then I'm going to save the book to make sure all the details are properly saved. So again, the service usually has business logic, so you may be thinking to yourself, Jonathan, like the repository already did all these things. Why have the service on top of it? Well, we're going to add business logic later. I just want you to see all of the layers talking to each other so that you see the full API in all of its splendor. And then when we add some more functionality, we'll come back here and we'll add some more stuff. All right, we're still not ready for a person to make a request yet, okay, because all we have so far is a service and we have the repository. The last thing we need to do is make a controller, because if you remember from earlier, the controller is actually the class that takes in the request and returns a response. Everything else basically has to do with data or business logic. The controller is essentially the first line that the client actually interacts with, okay, directly when they receive a request. So the next thing we have to do is we have to make a book controller, hook up the book service, and then we'll be able to see our API in all of its glory. All right, so the next step is to actually build the controller, which is going to talk to the service. And so we had our hello controller, and that was cool and all, but let's say goodbye to it. We're just going to go ahead and delete it. And we're going to create a book controller. All right, so again, the naming of your files, it depends where you work. Like your job will probably have some pattern that they follow. But since we're working with the book entity, the model is the book, that everything kind of follows that pattern, right? Book repository, book service, book controller. That way, each entity is going to have its own suite of different files that it deals with. All right, so in case we have other things in our API that are not books, they're going to have their own controllers, their own repos, their own services, etc. Now, we're going to go ahead and annotate the book controller, and we're going to call it a REST controller because this is going to be a REST API. All right, and so therefore we need to let Spring Boot know that this is not just a regular class, this is a controller. And also we want to be able to say, okay, cool, everything in this controller will begin with a certain endpoint. All right, they'll have their own endpoints, but all the endpoints will begin with this. We're going to do at request mapping, and then we're going to do parentheses and then quotes /API/books. Because this is a REST API, we want to be able to let the client know what information they're going to get if they go to /API/books. So this for Postman, I'm going to bring Postman up real quick. If we go, eventually what's going to look like is http://localhost port 8080/API/books. Well, if you're the client, it's pretty clear that you're going to get book information. So the resource is books. Okay, we use this term resource. Like when I call this API, I'm going to get information about books, or I'm going to be able to update information about books, etc. All right, it's all book themed. Okay, cool. Now we're not going to do the controller all at once. We're going to do kind of the easier stuff first, and then we'll explain some new concepts like path variables and all that good stuff. But we do know that the book controller is going to depend on the service, right? The book controller talks to the service talks to the repo talks to the database, right? And then it comes all the way back up. So you could kind of think that we go from the controller, okay, to the service, to the repo, then to the database. And then once we get the information from the database, the information bubbles back up. It goes up from the model to the repository to the service to the controller. So it's kind of like a merry-go-round. We go start at the controller, go all the way down, and then once we successfully get the data from the database, we go all the way back up. So it just goes back and forth, back and forth, back and forth. So the controller, its immediate neighbor is the service. So we're going to use auto-wired, which we used last time, and we're going to go ahead and inject the book service into the controller. Okay, nice and easy. Of course, we'll have to import the book service because it won't know what that is off the bat. And that's it. That's all we have to do for dependency injection. Let's do our first endpoint. So what I want to be able to do is in Postman, if I just do /API/books with the HTTP verb of get, then my expectation is going to be that I get information on all books. I should receive like a JSON formatted response with all the books that are currently in the database. Okay, so the thing with REST APIs is that they follow a certain convention. So their API is a general term for what we're building, and you probably have heard the term REST API, which is a kind of API. REST APIs have guidelines for how they're built. And the reason those guidelines exist is so that when you're working with a REST API, it's predictable how things are set up. I will not, just tell you everything, like all the guidelines. We'll just kind of learn them as they go. One of them is that if I do get and I do like /API/books, the expectation is to get all the books that I have in the database. So remember, we're using the get keywords. We're going to do @get mapping because that the HTTP verb that we're using is get. And then what we'll do is we'll say that this returns a list of books. Now you don't actually have to handle, transforming the information to JSON. Okay, so serialization or deserialization, all right, are terms that mean like either taking the JSON and turning it into Java or taking the Java and turning it into JSON. We don't have to worry about serialization or deserialization. Spring Boot, specifically Spring Web, will do that for us. We use this REST controller annotation, so it will do the job for us. So all we have to do is just say, okay, I'm going to give you back a list of books, and we'll call this method getAllBooks. Okay, we're going to have to import book, of course, and we're going to have to import list, because I won't know what these things are off the bat. All right. Now, this is a method, but I'm going to use a really weird term that you probably have not heard before. I'm going to call this an action. This is a controller action. Okay, and so this controller action is getAllBooks, and I think you probably know where we're going with this. We already have a getAllBooks method in the book service. That's it. That's all we have to do. We just essentially have to use get and then getAllBooks, and then we could actually run this and we can see what happens. Now, there won't be any books in our database. We could possibly add some. So let's go ahead and go to SQL. Let's add some books manually to our database so we can see some data come back. All right, so here we are in SQL. And again, if you haven't done any SQL before, you can go to the course on SQL to look that up. You don't need to know much SQL to do this course, though. I'm going to basically show you some stuff. So we're going to go ahead and insert some book information. One of the cool things Workbench does, it gives you little shortcuts. So go over to the books table, right click, and there should be a send to SQL editor, and there should be an insert statement. All right, so that way what we do is that it will actually write this statement out for us, which is kind of nice. I'll make it a little bit bigger. So it'll do insert into supermarketdb.books, and then it will do the column for you, and then all we have to do is replace these values, right, with what we want. So we don't need to actually have an ID, though. That's not necessary, because we're going to just go ahead and use auto increment. Okay, but we can do the author. So we can say the author is Isaac Asimov. Okay, and then the is available is going to be 1, standing for true. The ISBN number is, I have no idea what the ISBN number for this book is. We're just going to put something in there. All right, and then we're going to put a title. We're going to call it Foundation in Earth. Okay, one of my favorite books of that Foundation series. And we can make this ISBN look a little more realistic. We can do like, I don't know, 0061. Yes, I did when I looked up some ISBNs just to be persnickety. Okay, because it's got dashes in it. All right, so we're just going to insert this book into our database, all right, by running this query. All right, and there we go. And if you want to confirm that it's there, if we right-click on books and do select rows, we should, there we go, see Isaac Asimov is available, Foundation in Earth. All right, so you can see that this book information is sitting in our database. It's right here, all right? Okay, as part of our supermarket DB, like I'm guessing that we're like selling books out of a supermarket or something like that. Maybe it's like their book stand. Whichever happens to be. All right, so we're selling our books. We've got the book inside the database. Let's go ahead and run our API. All right, first make sure there's no problems. I'm gonna hit the play button and let it run. All right, there we go. Make this a little bit bigger so we can see. Yada yada yada. Okay, we'll wait till it says started. Okay, it says started. All right, let's go ahead and go to Postman and let's try this. All right, localhost port 8080/API/books. We'll do the get. And we'll see what happens. There we go. We got 200 OK, and you see we've got the book in JSON format. All right, with the stuff we just put in. And if we add more books, you'll see that it goes straight into an array. So we can go ahead and let's add another book to here. I don't know. We could say he also had Foundation and Empire, I believe. And we'll just increment this by 1 just to make it simple to insert. And so now I've just inserted this into the database, and so if I were to run this API call again, notice how we get all the new updated information. The ID auto increments, we've got the title, author, ISBN, and available. Everything is hunky-dory with a 200 of OK. All right, so we were able to actually, we've done it. Okay, we've actually connected the controller to the service, to the repository, to the entity. We've used all these 4 classes together in order to get all the books from the database. Now the thing here is details. All right, so if you understand that we're making a request, all right, we're sending a request to the API receives the request in the controller, and then you understand that how each thing is talking to one another. Everything else from here is just details about like how to receive a request, and like you want to see this part of the request or that part of the request. As long as you're understanding how these things are working together in general, I think that's considered a win for this unit. All right, in the next unit, we're going to start working through other parts of the controller that will require some more specialized stuff, all right, and more being able to change this URL to mean different things. But we'll go over it nice and slow, but for right now, I want you to like do this a couple times and really get a feel for how data that's in the database, right, that's here is ending up, okay, in Postman, given to us nice and neat as a JSON array of JSON objects, and how each of these things is talking to one another. The controller talks to the service talks to the repo talks to the entity, and then it back up all the way to the controller to give a response. Do it a couple times to get a feel for it, and then in the next coming units, we're going to deal with all the details. All right, let's continue on with our controller. And this time, instead of getting all the books, I would like to get a specific book by its ID, because the ID is unique for each book. All right, so how does that work as far as the request is concerned? So if we're thinking about the request, right, we're sitting in the client's shoes, they're a stranger using our API. How are they going to indicate to us they want book number 2 as opposed to like all the books? Well, what they would do is they would just put the ID after /books, right? So it'd be /API, /books, and then a number representing the ID of the book that they would like to get information on. And so this is called a path variable, all right, or path parameter, has different names, but essentially this is basically saying, hey, this part is the ID of the book I would like. And it could be anything. It could be 25. It could be 3,789. It could be whatever you want. And so it's variable. So we need to have some way on Spring's side to say, to read this URL, grab this ID at the end, and then do something with it. Which, of course, Spring is more than prepared to do. Now, we're still going to use the get HTTP verb, because the client wants to get information from the server. So we're still going to do get mapping. The thing, though, is that we need to have the ID. So in order to do that, we're going to actually do quotes / curly braces ID. And what this says is that, hey, this is going to be /API /books / and then some number I want to store as a variable. Public, and then let's do, this will return a book. And then we'll say get book by ID. And then here we're going to use another annotation because we needed to tell Spring that we want to grab the ID from the URL. It's not just part of the URL, it's actually a variable. And it's called a path variable. So you can use annotation. And keep in mind, this has to be named the same. I called this ID, both underscore letters. This is also called ID. That's how Spring knows that these two things are together. All right, now, as far as the logic is concerned, I need to go use the service to go get a book by its ID. All right, the service is going to be an optional of a book, right? Because the book could exist or it doesn't necessarily have to exist. You could search for a book and have it not be in your database. That could easily happen. So, of course, we need to import optional. And then we can use the book service dot get book by ID and pass in the ID. Now, how do we kick the book back up to the user? Because there's actually two possibilities here. Either A, they ask for a book that we do have, in which case we just give them the book information, or they ask for a book that we don't have, in which case, well, what do we do? What we want to do is, when we send them a code back, if you remember from before, we have these HTTP status codes, which lets the client know what happened with their request. In this case, we're going to tell the client that the resource they're looking for is not found. That is called a 404. All right, so they're going to send them a 404 if the book is not found. We're going to send them a 200 if the book was found. Now, how do we do that? How are we going to actually give them back a code depending on what happens? There's a cool class called response entity in Spring Web that allows us to handle this very situation. So we're going to rewrite this and put response entity and then use book as a generic. Okay, we're going to have to, of course, import this. And then all we have to do now is return response entity dot of passing in the book. All right, like this. So what does this mean? The response entity is sort of a nice way of packaging the response. All right, so for example, we have to have different codes based on what's going to happen. I want to send a 200 if the book exists. I want to send a 404 if the book does not exist. So let's run Spring and let's see what happens. I'm going to go ahead and hit run and then wait for it to start up. All right, I got it going. Let's give this a shot. I'm going to go to Postman. I'm looking for book number 2. Let's see if they got it. Yes, Isaac Asimov Foundation Empire. All right, I'm going to change 2 to 1. We should have a book number 1 as well. Nice, Foundation in Earth. Let's look for book number 3. There is no book number 3. Let's see what happens. 404 not found, which is correct. Okay, that is the correct thing to give back to the client, because now the client will be like, oh, I guess there is no book number 3. That's fine, I'll go look for another book. But now you can see that this part is variable. Depending on what the person puts in, they'll get back a different response and get a book, depending on which book, the ID of the book that they want. All right, so now we've kind of learned a little bit more this time around about 2 things. First, we use the path variable annotation to indicate that, well, something's a path variable. You'll have to, in the parentheses, put slash and then curly braces and then the name of the variable. I just put ID because that makes the most sense. It's not a reserved keyword. You could put aardvark in here and it would work just as well. We also learned about response entity, which is a way to package the response, okay, to the client. In this case, we have an optional of a book, right? Because the book could exist or not exist. If it does exist, we'll get a 200. If it does not exist, we'll get a 404. And response entity will take care of the proper code so that we can tell the client what happened with their request. So now we can use this path variable to let us to uniquely identify resources, which is something we're going to need for some of the other endpoints. All right, so give this a try. Make sure you understand like how this is working. All right, by try putting in like different things. All right, and get a sense for this. What we're going to do next is we're going to use this to delete a book. Hey, if you're enjoying this course and you're wanting to learn more, check out my website, codingyourcareer.com. I've got courses on everything from C#, Java, JavaScript, API development, modern front ends. It's a great way to deepen your skills and take your coding career to the next level. Now, let's get back to building my API. Let's do some more practice with path variables. All right, so we were able to get a book by its ID. We might also want to be able to delete a book by its ID. So if we click on this little drop down here, you'll notice that, well, there is a delete HTTP verb, which is pretty self-explanatory what it means. Okay, when you have the delete verb, you want to delete something. So what this means is that, hey, like notice how like the endpoint doesn't change. The URL has not changed. The verb has changed. And so because the verb has changed, that means the intent has changed. Now I hope you get a little bit a better sense of what these HTTP verbs mean, right? Their intent. My intent is to delete book number 3. If I have get, my intent is to get book number 3. All right, so we're going to combine the URL with the verb to indicate what we want the server to do. So let's go ahead and do that. Here, because the verb is delete, we're going to do add delete mapping. All right, so let me actually move this over. And then it's the same thing as here. We need to grab the ID from the path variable, and so we do. And then we're going to do public response entity, and we're not going to return anything because we're deleting something. What is there to return? So we're going to do void, and we'll do delete book, right? At path variable long ID. So as you can see, the part with the path variable is basically the same thing, right? Because it's doing the same thing. It's grabbing the variable from the URL and letting us know which book do we want to delete. Now let's look at our book service and see what we did for deleting the book. So if we look here, right, we delete the book, we have to find the book by its ID. If we don't find the book, we throw an exception, and then if everything's hunky-dory, we delete the book. All right, so basically what this is saying is if this throws an exception, then essentially the book will be was not found. All right, so if the book was not found, then we will not be able to delete it because that book doesn't exist. But if it was found, we can delete it. So we're going to use a try catch here. Try catch, and then we said, what was it? No such element exception. Okay, I'll show you another way to do this later when we refactor this. Okay, so we're going to try to delete the book. So we're going to do book service dot delete book ID. All right, so if this goes well, then we're going to return a response entity. Okay, actually new response entity, my bad, new response entity. And then what we're going to do is we're going to say, okay, cool. We can just put brackets here. It's a void, but you don't have to like repeat void. You can put that here, but you can actually leave this out so it's a little bit easier to type. And then we're going to put parentheses. I'm going to do HTTP status code. No, HTTP status. Okay, dot, and we'll do no content. This enum HTTP status is really helpful because as long as you remember that it's no content, it will handle the actual like number for you, right? Like what the actual status code is supposed to be, even if you forget. So again, new response entity, and then in the constructor we're going to put the enum no content. Okay, when we delete something, we're basically saying, hey, I deleted it, but there's no content to give back to you, and you shouldn't expect any. So when we delete something, we want to give back no content. Now, if an exception was thrown, okay, we want to be able to say, okay, cool, we're going to return a new response entity, okay, and the exception was thrown because it wasn't found. HTTP status dot not found, okay. We did not have, like, we basically just did not find the book you wanted to delete. All right, so let's go ahead and give this a shot. I'm going to go ahead and run. Remember when you add stuff, when you type like new endpoints, you have to restart Spring Boot. Like, so one of the common beginner mistakes is, hey, I wrote some code, but why is Spring Boot not doing the thing that I programmed? Probably because you didn't recompile, because you had to compile again before the changes will take effect. All right, let's wait for it to get started. All right, there we go. So let's go here. I want to delete book number 3. Okay, there is no book number 3, so we get a 404 not found because there is no such thing as book number 3. I want to delete book number 2. There is a book number 2. Okay, 204, no content, meaning the book was successfully deleted. So now, if I try to get that book, okay, it's 404 not found because it's gone. Okay, be careful with deletes. Deletes tend to be dangerous just because like the content is gone. There is a thing called a soft delete, which I'll show you later, which is a nicer way of deleting things. But this leaves a hard delete, meaning that when it's deleted, it's gone. Like it's very difficult to recover it. But that may be fine. Like I said, it may be okay to do things like that. All right, so we use path variables with the delete mapping, and also we use a response entities that we could give different status codes based on what happened with the client's request. So we did new response entity, and then we passed in this enum, HTTP status dot no content, because we deleted something and we're not returning anything, and there's nothing to return, and then not found in case we didn't actually find the book. And we also use a try catch, which is very common to use in controller actions. Okay, so now we can get all the books. I can get a book by its ID. I can delete books, but I'd like to be able to add books now because like trying to go into my, SQL Workbench and manually adding books is a kind of a drag. So I want to be able to create new books through the API. So we'll do that in the next lesson. All right, so we can delete books. We can get all the books. We can even get books by their ID. But what about creating a new book? Like what if we want to add books into our record, okay, to our database? We can. So the verb when you want to create something is post. All right, so you're going to find post here. Post indicates that the client wants to create a book. Now remember, the people writing the server have to actually still write all the logic to do all these things. These verbs don't magically do stuff. They're only there to tell us this is the intent of the client. So we're going to keep the endpoint the same because it's going to be /API/book. So the intent is I would like for you to create a book. Okay, cool, but books have a lot of information attached to them. So if we go back to our model, okay, books have a title, an author, an ISBN, and whether or not they're available. Now, the ID, we're gonna let the database handle the ID. We're not gonna actually have the client set the ID of the book. Okay, that's not their job. Our database can handle that. So we're gonna let the client kind of set these things. All right. So whether or not, like the title of the book, the author, the ISBN, and whether or not the book is available. So, but this is quite a bit of data though. It's like 4 pieces of data, and for even larger entities in the future, they can be pretty big. So how are we going to get all this data over when we only have like this URL here? Are we going to start putting in the data in here? You could, but that's not really a great way of doing it. Requests have different parts, like I said earlier in the previous lesson, and so the part of the request we're now going to use is the body of the request. So you can click on body. The body of the request is where we can put larger pieces of data. So I want to send, for example, send over the data necessary to create a book. We're going to hit raw, and then we're going to have, it should say JSON. If it doesn't say JSON for you, click this over here and make sure it says JSON. So basically, APIs nowadays all use JSON. Back in the day, there was a JSON XML war where people were like fighting over which one to use, and JSON won out. So we're going to be sending JSON over. Again, you don't need to know anything about JavaScript really to do this course, okay? But you know you're going to learn just a little tiny drop. So JSON, we're going to create an object. We say it's an object because it's got these curly braces. All right. So in JavaScript, you do an array with square brackets like this, and then you do an object with curly braces. And then it's just simply a key value pairs. What is the property? What is its value? So we've got title, author, ISBN is available. So let's go ahead and put that in. We're going to put title in quotes, then a colon, and then what's another Asimov book? iRobot. All right, so there we go. Notice how I'm separating the key and the value with a colon. All right, and then the key is in quotes, and then the value is with the value. In this case, the value is a string, so it's in quotes. I'm going to do a comma, so I need another one, so I'm going to do the author and the ISBN. So we got to do author, Isaac Asimov, and then the ISBN, which is, I don't know, just some random numbers. All right, so again, notice how I put a comma at the end of each line, and that these begin with a lowercase letter. So this is lowercase t, lowercase a, lowercase I. All right, and then we're going to do is available. Let me double check to make sure that's what I actually said here. Okay, it's got to match up with these. Like if this says title, the JSON needs to say title. If this says author, the JSON needs to say author. So that's why I double checked to make sure that I got the naming correct. All right, and then here for Boolean values we can put true or false. So you don't have to actually put this in quotes. You can just type the word true for a Boolean value, and that's fine. So here we go. This is the body of our request. Now, not all requests have to have a body. So for example, when we did our get and delete requests, they didn't have a body. Well, that makes sense, right? We're not sending over a packet of information. We're not trying to create a new book or do anything like that with a get request or a delete request. But for a post request, yes, we are trying to actually tell the server, hey, I need you to create a book. So if you understand this so far, then when we go to make the actual controller endpoint, it'll be fairly simple. The controller endpoint will have to read the body from the request and then turn this into a Java object, right? So we have to have a Java object, a POJO, a plain old Java object that has a title, author, ISBN is available. Then we need to take that object and send it to the database and save it as a row in our database. All right, so we'll do that in the next lesson, but I wanted to first go over how post requests are done and what the body of the request actually signifies. Okay, the body of the request is typically with posts or puts or post, puts, or patch. All right, because those HTTP verbs require more complex data than what we can put inside of the URL. And it's a JSON object, so it's JavaScript. So to indicate a singular object, you have a curly brace and then key value pairs. The keys are in quotes, they're separated by a colon, and then you have the value. And then you have a comma at the end. Make sure you don't put an extra comma at the end of the last one. So for example, is available is the last thing in the list. If you try to put a comma at the end of it, you'll get an error like this with little red, because comma should only come at the end of a line if there is a next line. Is available is the last thing, so there shouldn't be a comma after it. Little small JSON thing, but don't want you to tear your hair out. All right, in the next lesson, I'll show you how to actually consume the body of the request and then go ahead and save this book into our database. So we can use path variables to take the variable from the path and then use it. But what about posting? So now that we understand what a request body is, how do we grab the request body and use that to save a book? Well, actually, it's quite simple. So first we're going to do post mapping because we're doing a post. Then we'll do public response entity, and then we'll do the generic with book, and we'll call this create book. Now, why are we returning a book? Because when people create things, they need to get the ID back of the thing that they created. Remember, the client is not going to send us the ID because they're not going to know it. The database decides what the ID is going to be. So obviously, the best thing to do is let them know back when we get the ID. So we're going to give them the book back that we created. The main thing is, how are we going to get the request body, right? Because the request body is going to be JSON, and I need to turn that JSON into Java. And it actually is really easy. You don't really need to do much of anything. It's another annotation. So we're going to do @request body, and then we'll grab the request body. And I want you to take the request body and turn it into, oops, I'm sorry, I said the word body. There we go, book. I want you to turn it into a book, our book entity, all right, which we got here. All right, so let's go ahead. Now we've got the book from the request body. We can take the book and we can save it. So I'll do book, new book is equal to book service dot create book, passing in the book. And then we'll return a response entity. And I'm going to switch it up a little bit here. I've been showing you different ways to use response entity, and you're like, Jonathan, why isn't all of them like the same? I just want to show you different ways of doing the same thing. So we're going to return a status, and then we're going to say created, because when you make a new entity, you return a 201, not a 200. Okay, so it says, yes, we successfully created the thing you wanted to create, and the body of the request is going to be new book. Fantastic. All right, so yes, we could have done this another way. I just want to show you that there are many different ways to do the same thing. All right, so let's go ahead and actually go to Postman and create a book. Okay, here we are at Postman. I've got Hyperion by Dan Simmons, and I'm going to put it's available, and then we're going to post the book and see what happens. All right, so there we go. 201 created, meaning it's successfully created, and then we have Hyperion by Dan Simmons. But there is something a little bit screwy here, right? This is available is true, but this available is false. And so what the heck is going on? The reason this is happening is mainly because of Lombok. I did say back at the beginning, I did want to show you Lombok, but Lombok isn't perfect. It does definitely cut down on the boilerplate we need for our code, but it does cause screwy things to happen. So for example, when you have a Boolean value, Lombok does generate the getters and setters for this property, but it does it like get is available. So what do you mean by that, Jonathan? like let's look at this book, right? So I'll do new book dot, and you see we have the normal getters, right? But let's do is. Okay, so it has is available, all right? But the problem is that it won't necessarily go properly to the property here. So we have to basically say, let's go back to here. So we do like new book, and then we look, it says is available, right? And so that you would think that that would like match up, but it doesn't. So because of what Lumbug does behind the scenes. So in order to fix that, what we're going to do is we're going to basically do a JSON property, okay, here. And then we're going to do parentheses, and then we're going to do is available. That way it will properly match up the two. So I'm going to go ahead and rerun this. Okay, and then what I'll do is we'll just post it again. So this time we'll do Hyperion, I think there's a second one. All right, and there we go. And notice how the is available will now be set properly, all right, because of the way Lumbug does the getters and setters. Honestly, like this sort of thing can be a little bit annoying and unexpected. That's why I purposely put that in there, knowing full well this would happen, because I wanted to call out this thing that Lumbug does, especially with Booleans. It can be very unexpected. It's a great time saver for other things, but every now and again it will do something unexpected and weird, and yeah, you'll have to end up tracking it down. Now, one other thing I wanted to kind of show you is that in the console here, while Spring Boot is running, do you see how it actually shows like it insert into books? So it actually, if you do like database operations, it will show you in the console as they happen, which is kind of cool. All right, cool. So now we've got the create in our CRUD functions, right? So we can read. We've got the R, because we can read by ID or read all the books. We've got the delete, and we've got the create. Now, the last thing we've got to do is update, all right? So we're going to do our put mapping. So we'll handle that in the next lesson. All right, now for the last method, we're going to do the update, right? Because we're doing create, read, update, delete. We've done everything except the U. All right, so to update things, okay, so to take something that already exists and change one of the values within it is an update. And you have two options. You have put and you have patch. The difference between the two is basically, are you updating the entire object or are you updating one property of the object? Put is where you get to update the entire object. So title, author, ISBN is available. They're all up for grabs. Patch is where you specifically want to patch or just update like one thing. Like maybe you allow the author to be updated. All right, so those are the two different verbs go for. We're going to do put. All right, now notice put will require some data, right? Because we could be sending a bunch of things over. We're going to be sending a JSON object over, so we will need the body to the request. So puts and posts are very, very similar. Now, the only thing is we want to make sure that we have the ID of the book in question that I would like to update. So this is book number 2. And so to indicate this specific book I want to update, we use a path parameter like we did with get book by ID. So it looks like we're going to have to use two things. We're going to have to grab the ID from the URL, and we're going to have to be able to take the body of the request and turn it into a Java object. But we can do both things, so that's no problem. We'll do at put mapping, okay, because we're doing a put, and then we will grab the ID from the URL like we did before, and we're going to do public response entity, and we're going to give back a book because we're updating it. Update book is the name of the method, and then all we have to do is we'll use path variable for the ID, and then we'll use request body for the book itself. So it's basically like a combination of post and like get by IDs, right? So we're using this part, the path variable, and we're using the request body like we did before. So we're just combining the two into one, and that's fine, no big deal. All right, now to update the book, we actually need to go ahead and figure out like whether or not the book can be updated. So what I mean by that is there has to be a book with this ID in our database, otherwise there's no point in updating it. Let's look at our update logic here. So essentially what's happening is I'm looking for the book by its ID, or else I will throw a no such element exception. So what we're going to do is we're going to do a try catch, because this could fail. So we'll do a no such element exception. All right, and then what we'll say is that we're going to go ahead and update the book. We'll do, let's do, what does this return again? Book service returns a book. Okay, cool. So we'll do book, updated book is equal to book service dot update book. It will pass in the ID and we'll pass in the book. isn't it nice that like we're letting the service and everything else, down the road figure out how to actually do this? We could just, use the update book method and go on with our lives. And so let's say there's no exception thrown. So if there's no exception thrown, then what we can do is we can just return a new response entity, all right, and throw the book in there, the updated book in there. Okay, and we're gonna let the person know, hey, this is what you get back. Okay, and we also need to give it a status. So with update, we'll just do http status.ok. There we go. All right, so you can also use it like this. You can put the thing you would like to serialize in the JSON as the first argument, and then the status you can put in as a second. I personally like this, but like I said, I wanted to show you the various different faces of response entity and how you can use it. All right, so this is the happy case. If we don't find it, we can just return a new response entity, okay, with a status of not found. Like we tried to update book number 10, but we don't have a book number 10. Super sorry. All right, that's it. Let's restart. I'm going to restart my Spring Boot application. Let's see if we can test this and see how it works. All right, let's go to Postman, and let's say I wanted to say that this is a different ISB number, right? So I'll say, cool, this is a different ISB number. We know ID number 2 exists, so we'll go ahead and do a put. All right, and notice that it changed to 345. So just to even bring home the idea, I'll do a get by ID, and it should have the update information inside of there, right? And we can do multiple ones. Maybe I want to change the ISBN again, and I don't know, 67, and then make it go false, all right? And then we can update it, and notice that the data about the book changes, all right? So now we have a basic CRUD API. So again, nothing super special, but you guys are just getting started off, so it's good. So we were able to create books. Okay, so remember, CRUD stands for create, read, update, delete. CRUD, create, read, update, delete. That's what it stands for. And so we're going to create books. We're going to read books by getting all the books or by their ID. We can update books, and we can delete books. All right, so we can do all the basic CRUD functions necessary for our grocery store library. Like I'm picturing like one of those racks where they sell books in like grocery stores sometimes, or like the big like the Walmarts and places like that. So you can use your imagination. We're selling books off a book stand, and now we're able to do basic CRUD functions. But this usually is not enough for like most regular APIs, and so there's a lot of little details in here. I wanted to get a basic API going so that you could use Postman and see all the different verbs, understand path variables in the request body. But now the next step is to start adding a little bit more spice to what we've already done. So you have the core of what an API is, right? But now we're going to go in and learn all the different things we can do with an API, including like using query string parameters, how to validate things. So buckle up. There's a lot more to do with an API, but do try to get to this point, all right, so that you're able to actually use it. You can see the data appear in the database and how the whole sleigh ride goes from beginning to end. But from here on out, we're going to learn some more very cool techniques that Spring allows us to do to really make API work fast and easy. Now, CRUD functionality is all well and good, but we are going to build an API that does a little bit more than just the basic create, read, update, and delete. And so what we need is we need to be able to, for example, look up books by their title or look up books by their author. Because, well, that makes sense, right? People coming to our supermarket and they're looking for books on our website, and we're going to see, hey, like they want a certain title or a certain author, all right, or maybe a certain ISBN. So the first thing we're going to do is we're going to have to make some repository methods that are going to be responsible for getting the book by its title, because out of the box we just get the basic CRUD functions, get all books, get book by ID, etc. So we don't get anything more special than that, because there's no way for the JPA repository to just psychically know what entities we're going to be using. But they have it really easy to actually make these queries. So we don't actually even have to write the implementation. We just have to add methods, signatures, to our repository, and then we'll let the Spring Data JPA literally do everything else. It is absolutely bonkers. All right, so we want to do let's first make a method to find a book by its author. All right, so let's say someone's looking for George R.R. Martin or whatever they're looking for. All right, so let's imagine what this method would be like. If we were to write this method, we would have like a name, right? It would probably take in an author, right? Because the person's searching for an author, and it would return a list of books. All right, so that makes sense, right? The person searches for an author. They could get no books. They could get 10 books. They could get 1 book. So returning a list of books makes sense. So let's start writing the signature. And again, we don't actually have to write any logic. We just have to write the signature. We're going to do list of book. And then we're going to actually name the method. Now, here's the trick. I'm going to actually import list in a second. But the name of the method will actually tell Spring Data JPA what SQL query to run. I kid you not. You will be able to, all you have to do is name the method by the convention, and then everything else Spring Data JPA will take care of for you. We are going to do find by. Okay, so that's our first keyword, find by, because we like to find a book. So you do find by, and then you give the name of the property you'd like to search for. So for example, in this case, author. Okay, author is one of the properties of our entity here, so we're going to find by the author. Now, we all know that when people put, information to a form, they don't necessarily spell and type everything correctly. So I don't really care if they do uppercase or lowercase letters. I also don't care if they just put part of the author's name. So maybe they remember the guy's name had Martin in it, but they don't remember it was George R.R. Martin. Well, we can say containing, meaning it contains the author, the string that they put in. And we also can put ignore case. Then we'll say string and the author of what they want, of the person they want to look up. Go ahead and import list, and that's all we have to do. We do not have to write actual code to search for an author by their name, by whose name contains a certain string, ignoring the case. We just have to write the method in the correct order. So we start off with find by, then we have the name of the property that we're looking for, and then we have some modifiers. So for example, I can only care if it's containing, if it has the name within the name, and then I am ignoring case. So what I can do is pause the video and think about how it would do this for title. We want to also look at books by their title. So pause the video and think about it. Using this as your model, how would you write a method to find a book by its title? Okay, so we're going to do list book. It starts with find by, title containing, ignore case, string title. Isn't this beautiful? We don't actually have to do anything. We don't have to write actual code to do this, or any SQL queries or any of that nonsense. We can just basically say, hey, I named the method this way, and Spring Data JPA, you should be able to figure out what this does. Now, what if you wanted to find something by both author and title? Well, that's easy. You can combine the name. The naming is what, as long as it fits the pattern, the naming is what does it. So find by author containing, ignore case, and then and title containing, ignore case. String author, string title. Notice how I use and here. Right? All I did was basically take these two. I started with find by, author containing, ignore case, which was this first one. And then to latch this other one on, I use and then title containing ignore case. You don't have to type find by twice. Okay, it's not necessary. All right, that's it. We did the repository. We now have methods that will be able to search for books by their author or their title, or both the author and the title. And now all we got to do is hook this up to the service, and then hook this up to the controller, and then we'll be able to move forward from here. So if we're going to do this in the service, let's actually do that right now while we're at it. We're going to go ahead and do public list of book. We'll say get book by title, for example, string title, and we're going to return the book repository dot, and now you see these methods come up. Find title by ignoring case, and we'll do title. Oops, gotta put the semicolon here. See, just that easy. Now I don't actually have to write the actual implementation for this method. I can just basically just use it. So I'm going to go ahead and do that for author. Get book by author. String author. Let the repository take care of that. And then we can do public list of book. Oh, I didn't mean to use the full one. Find by author. There we go. And we'll use the big one here. Get book by title and author. Author. String title, string author. We'll use this huge one and put the title in, the author and the title in. And there you have it. Now the service has got those two methods all hooked up. And then in the next section, what I'm going to show you is how we use query string parameters. What that means is what we want to filter the books. These are like filtering operations. I'm going to, there's a whole bunch of books and I only want some of them. So how do I filter? How do I indicate to the API that, hey, I don't want a single book or all the books. I want books based on certain criteria. We want to filter the books out by their author or title. So how do we do that? Okay, the next stop is going to be the controller, but we'll handle that in the next lesson. All right, so how are we going to actually search for books in terms of the URL? So we already have the repository that will go and do all the SQL stuff for us, but what happens if we want, how are we going to indicate in the URL itself that, hey, I'd like to search through the books? Well, remember, we're doing a REST API, and so REST APIs follow certain conventions. And the whole point is that as long as everyone's following the REST API conventions, even though we're total strangers on the internet, we can still figure out what we want. All right. So here, what I'm going to do is I'm going to say, okay, cool. We're going to have /API/books. Books is the resource, but I don't want to do CRUD functions with the book. I want to specifically search books, which makes sense, right? We have books, which is the resource, and what are we doing with the books? We're searching through them. Okay, so far so good. However, there's different ways to search through books. You could search by the title, you could search by the author, the ISBN. There's a bunch of different things we could do. So how are we going to indicate what we're searching for? Well, here's where query parameters come into play. After the word search, we're going to put a question mark, and then we're going to put title equals, and then the title of the book that we want, maybe what's it called, Ice and Fire, or Fire and Ice, something like that. I forgot the George R. R. Martin book. We'll just do Foundation. All right. Notice how Foundation does not have any quotes around it. It's just Foundation. And also notice that cool thing that Postman does is it gives us a little GUI for keeping track of query parameters. So notice how this is checked off. And if I uncheck it, watch what happens to the URL here when I uncheck this. See how it goes away? And when I recheck it, it puts it back. So if you don't want to actually type everything out up here, you can use these boxes down here to achieve the same effect. So what this URL means is the books is the resource. I'm searching through the books, and I'm specifically searching for books with a title of Foundation in it. That makes sense to me. So looking at this URL, it's very clear what the intention of the client is. You can add more than one query parameter, no problem. Let's say we wanted to do a second one. If you do a second one, you have to use AND to append the next query parameter. So maybe we can do author equals Asimov. All right. And so you'll notice that, again, what you'll see here is Postman will have check marks. And so if you don't want to type stuff up here, you can, of course, type things down here and they'll appear. So, for example, if I did ISBN, right? I could do ISBN and, I don't know, some numbers. Okay. And there you go. See how it popped up and it added to the URL for us automatically. So you can use the GUI. You can type it in by hand. It really doesn't matter. It comes up to the same thing. All right, but the main thing here is query parameters are you have the endpoint and then you have a question mark. Question mark means the endpoint is over. Everything to the right will be query parameters. And then you have the name of the parameter, in this case title is equal to, and then the value, Foundation, no quotes. If you have more than one, you'll put an and sign in between them and follow exactly the same pattern all the way through. Now, one little small note, it's the common beginner mistake. Just because you put something in the URL does not mean that the server just magically does something, right? We are forming the URL a certain way because we're trying to stick to the convention so that other people, like the server, right, the strangers, the people who are making the server are strangers, right, will be able to figure out what it is that we want and they will follow suit. We still have to program Spring Boot to search for books by title and author properly. That's on the server. So when you're building your API, you still have to program it to search for things properly. That does not just magically happen because you wrote the URL the proper way. So I just want to make sure that's absolutely clear. So the question then becomes, we're going to have to add another get mapping here to do search, and we're going to have to figure out how are we going to grab this information from the URL. Well, lucky for us, we're using Spring Boot, and if you haven't already guessed it, there is an annotation, much like path variable and request body that we've done before, that will help us grab the information from the URL. In the next video, we'll handle how do you grab query parameters from the URL in Spring Boot in the controller. All right, let's do this. We're going to add a new mapping for search. So we're going to do get mapping, except this time we're going to add parentheses and do /search, all right? Here's a key thing to remember. So you can't have multiple get mappings that are identical. So we have 3 get mappings, and that's fine, but they're not identical. The URL is easy to tell the difference. This will be API/books/search. This will be /API/books. This will be /API/books and then / a number. So it's easy for the computer to tell which one's which. You can't have 2 get mappings. So for example, if I had 2 methods that both had a get mapping and there was nothing to differentiate them, then Spring is going to give you an error because it would be like, I don't know which mapping to give you. All right, so we're going to put /search because I want it to be /API/books/search. And we'll do public response entity. And we're going to return a list of books. And then we'll call this search books. All right, so response entity, there we go. All right, so how do we grab the query parameters from the URL? So let's say, for example, the first one, they've got title. So $title equals foundation. How do I grab this? Well, it's pretty easy, actually. What we'll do is we'll go back to IntelliJ, and then we'll basically say in here, inside of the parentheses, that we're going to put @request param, and we'll say required equals false, maybe, and then we'll say string title. All right, so what this does is it says, look, go into the URL, go look to the right of the question mark and find something that says title, and then grab the name of what they put in here and grab the value. And so we're telling it we're looking for something called title. The fact that we named this variable title is not by accident. It matches, okay, this part here. They need to match. All right, so we grab the title. Cool. So once we've got the title, it's actually not too difficult to do the rest of the logic. We'll create a blank list of books just for right now. We'll fill this in later. And we need to do a series of if-else statements because we don't know if they gave us a title or not. They could give us a title. They could give us the author. So in fact, we need to account for that. So we're going to do first the title, and then I'm going to do @request param, required equals false, and I'll do string author. Right, because they could give us a title, they could give us the author, or they could give us both. We give them the flexibility, the client the flexibility of how they would like to filter their data. Now, they don't get to filter by ISBN, but these are the 2 options that they get. So here we just have if statements. If title does not equal null, okay, so if they give us a title, right, so otherwise it'll be null, and author does not equal null. So this is the case where they gave us both title and author. Else if, all right, title does not equal null, meaning they just gave us the title, or author does not equal null, meaning they just gave us the author. Okay, and then all other cases, if they don't give us anything, we'll just give them back all the books. All right, so the first case is they gave us a title and an author. This is just they gave us an author. Gave us a title. This was they gave us an author. My apologies. And the last one is they didn't give us anything. Okay, so there's 4 options. There's 4 outcomes. Well, we've already got the service and the repository built, so all we have to do is return book service.getBooks by author and title. All right, so we're going to put the title in first, and then we're going to give them the author. Okay. Now, here we're going to have to actually, oops, I forgot, we're going to use the book thing here. So we'll do book, we'll call this books actually, so it makes more sense because it's plural. Books equals, all right, cool. And then we'll do books, in this case, equals book service.getBooks by title, and we're going to pass in the title. In this case, books is equal to book service.getBooks by author, passing in the author. And the last one, books will equal just get all books because there's no filter. At the very end, we're going to return the response entity of OK, and then we're going to do pass in the books. So essentially, we're just doing some filtering with some if statements. So this was actually not very difficult. All right, the request param annotation will grab the parameter from the URL based on the name of the variable. So here it says title. We also can basically say whether or not they're required. Sometimes they might be required. You might have to tell the user, you must, if you're searching for a book, you must give me a title. But in this case, we're going to let them choose, right? They may just want the author or they may want the title. So making it required is going to be too clunky. We'll just make it that they choose. And so we just basically check, did they give us both of the query parameters? Yes, then give them back the appropriate data. And then after that, we just return it with a 200. Remember, OK is 200, and then Spring Boot will turn it all into JSON for us. All right, let's actually try this out and see if it works. So I'm gonna get Spring Boot fired up, and then we'll give it a shot. All right, here we are in Postman, and I'm gonna go look for Hyperion. All right, because I know that's in there. Title equals Hyperion. So let's see what we get. All right, I got Hyperion 2 by Dan Simmons. So I got two different results. So I was able to search by title. All right, well then let's go ahead and search by author. The author is Simmons. Notice how I'm going to put just his name, right? And I'm also going to make this a lowercase s to kind of show you what happens. All right, so it's just that his name contains Simmons, not that his name is Simmons. So, because remember, people won't necessarily remember the author's full name. And also notice that because I did ignoring case, meaning they could put this in all lowercase letters, and it doesn't really matter. All right, and so we could do both. We can do title and author. All right, I want Hyperion 2. All right, let's see what happens. Okay, so notice that we can put spaces in here. I did that on purpose so you can see that you can put a space in here. And notice that we got Hyperion 2 by Dan Simmons, right? So we got to search both by title and author. And if I remove both of these, I don't do either parameter. So I just put search, and it'll give me all of the books that are in the database. So as you can see, query parameters allow us now to search through, all the books. And believe me, for our little like grocery store book stand, there could be quite a few books to search through. All right, so hopefully you got the hang of it, so you understand what request param does. All right, we'll go over some more details as time goes on, but for right now, this will allow us to filter our books quite easily. And so hopefully you're kind of understanding the power of layered architecture too, because once we set everything up with the book repo with these methods, right, then it was pretty easy to hook them up into the controller, and then everything runs smooth like butter. All right, so now that we've built a very basic REST API with CRUD functions, we're going to delve deeper into the different layers of the application and learn more about, what can we do with them. So first, let's deal with Spring Data JPA and specifically entities, right? So entities are these classes that represent tables in the database, right? So for example, this is the book class and it represents the books table in the database. We know that from this entity annotation. So we're going to use annotations and learn more of them, all right, than the basic ones we learned when we first made our API. So let's go ahead and make a class in the models package. We're going to call it user. And we're going to annotate it with @entity to let Spring Boot know, hey, this is not just a normal Java object. This is going to be a table in the database. We also can say that it has an ID, which will be the primary key, and we mark that with ID. And we also mark that with generated value, strategy is equal to identity. Okay, and what this does is it says, okay, cool, this property right here is going to be the primary key, and how do we auto increment it, or what's our auto increment strategy? So we're going to auto increment it because it's a number. Now remember, for primary keys, you don't necessarily have to do a number. Some people do strings as primary keys, which is fine. But if it's a string, you're not going to be able to auto increment it because it doesn't make much sense. So you may have some other strategy for how you deal with primary keys, but we're just going to use a number and using generation type identity because that's the easiest thing to do. Now, for the other parts of the entity, you may have some properties, right? Some columns that represent different kinds of data. And the thing you want to do is you want to be able to validate your incoming data. What that means is you don't want bad data going into your database. For example, our user might have a username, so do public string username. But maybe username is mandatory. Oops, let's make that a capital S. Okay. Maybe username is mandatory, right? Like they have to have a username. There's no way they can't have a username. Maybe our whole thing breaks if they don't have a username. So what do we do? Because right now, as it stands, someone could make a user with no username, and that would be bad. So we need to put some validation on our entity to make certain that, hey, you have to give me certain pieces of information. You can't move forward until you do. So if we go to the POM XML, we're going to need to actually add something before we can do that. It's going to be the Spring Boot starter validation. So here is the artifact ID. I have the dependency right here, so you honestly can just type this in to your own project. or you could look at Spring Boot starter validation, because Spring Boot used to have validation out of the box, but it doesn't anymore. So you're going to have to add this dependency in order to do it. So these annotations I'm about to show you are basically assuming you have this package. So make certain this is installed. Remember, you can just paste the dependency into this file. You can right click and you can do Maven and then reload project. All right, so that way it downloads the dependency. So here we go. And let's say that we have username, right? So username is something we have to have. You can't not have it. So what we could do is we could say username is not null, right? Notice that's from jQuery.validation.constraints. You'll notice that there was another not null in here from work.etler. I don't know what this one is, and we don't care. We want the jQuery validation one. So just to let you know about that. So we have not null, and then we have at column nullable equals false. Now you may be thinking to yourself, why do we have not null and column nullable equals false? Like, don't they mean the same thing? They do, but in different arenas, different circumstances. The not null has to do more with Java. The at column has to do more with SQL. The at column says, okay, when we make this SQL table, make sure that in SQL it says that this column is not nullable, right? So it's has to have a value. So that will check on the SQL side, like when we actually make the table, SQL will have a constraint to make certain that the column is not null. On the Java side, like while we're in Spring Boot, while this user is in Java form, then we can also use this to check to make certain that it's not null. So you have to kind of remember that this user class actually represents a table and a Java object. So we could be dealing with it on the SQL side when the data tries to be written to SQL, and we can also deal with it on the Java side where we get requests and return responses. So you'll see a little bit later what that means, but I think hopefully that kind of clears it up, because what can happen is that maybe like in Java, right, you don't check to make certain that the username is null. But then when you get to SQL will throw an error if you try to put in a null value for username, because we wrote the column that way, we wrote the table that way. So this is sort of just making double sure from both sides, both while we're running a Spring application and also while we're putting information in the database to make sure that it's correct. All right, so now we know how to make something not, to ensure that it exists. We also can ensure that it's a certain size. So for example, I could put at size, and let's say like the minimum length for a username is 8. And then we of course need to import this because it won't know what it is off the bat. Okay. There we go. And now we basically say, hey, your username needs to be a minimum of 8 characters, and maybe we can put max as 20 characters. We don't have like abnormally long usernames. All right, so now you can see what I mean by validation. So this will make it so that when you build a SQL table, it will have rules as to what data it expects, so that way you don't get bad data into your database, and it could possibly cause crashes or weird bugs with the rest of your program. All right, so the next lesson I'm going to teach you more of these validation annotations, but these are like not null and at column nullable equals false, or like S tier, and then size is also very, very useful. But there are other ones besides these that we can use for validating our entities, and they're all good to know. But hopefully, what Spring Data JPA does, besides just making life easier for us, it can also help us add validation to our tables. We'll learn more about it next time, but hopefully the ones you have so far are clear. All right, let's continue on with more annotations. All right, so we've got a user, they've got an ID, they've got a username, and let's go ahead and give them an email. All right, so public string email. Now, the cool thing about these annotations is that they knew that there are a lot of common use cases, like, well, emails. We want to make certain the email is of a certain format. It has the @ symbol, and then it's followed by something.com or something.net. So it's actually really easy. All you got to do is just do .email. That's it. Nothing more to it. Right? We'll also want to make certain that it's not null, because they need to have an email when they sign up, and that in SQL, the column will be null will be set to false. All right, perfect. So we have the @email annotation, which is actually pretty cool. It makes things very, very easy. Now, what about enums? Let's say we had an enum. Let's say, for example, I'll make an enum let's make a enum in the models folder. And let's say, for example, we had roles, like a user role. So we'll do a user role, and we'll make that an enum. And then we'll say there's admins, there's guests, and there's users. All right, so we have 3 different kinds of user roles, right? Admin, guest, and user. How do we indicate that with an annotation? Pretty easy, actually. So we're going to do, oh, I should have said these are private, actually, now that I'm noticing it. Private, private, and private, my bad. All right, so private, and then we're going to do enum. Actually, it's private user role, user role. All right, where we're using the enum that we made over here, but how do we indicate that in the database? Like, how do we do enums in the database? There's 2 ways to do it. You either store it as a string, where it will be admin, user, or guest, or, remember, enums have integers associated with them. So, for example, admin is 0, and guest is 1, and user is 2. All right, so you can see this is enum constant ordinal 2 right here. So enums can be represented either as integers or as a string, which represents the actual string value. Well, you get to kind of choose, actually, which one you'd like to do. So we can do enumerated, and then inside the parentheses, we can put enum type, and we have two options. Ordinal means you'd like to put the integer in the database. String means you'd like to put the actual string value in the database, right? So if we do enum type.string, if you go to the database, it will say, for example, admin or user. If you put an ordinal, it will say 0, 1, or 2, okay, depending on what it is. All right, so enums are actually fairly easy to handle. So now, now you can see how powerful this stuff is, right? Because we really don't want bad data going in the database literally ever. So we're going to make sure that that never actually happens. All right, so these entities are actually pretty cool. You can even use regex. Okay, so regular expressions allow you to take strings and see if they match a certain pattern. So let's say, for example, we have a private string phone number. Phone numbers are typically strings. I want to make certain that they put the phone number in a certain way. All right, we can use regex. So you can put @pattern, which says I would like to use regular expressions. All right, and then let's go ahead and import this. And then you can actually just put the regular expression in. So I'll do regex, and then I'm just going to paste this long thing in for phone number. Okay, I'm not the world's greatest regular expression expert here, but basically you want all this hieroglyphics is regex if you ever want to get into that. You also can put a message if they get it wrong. So, for example, if it's not valid, you can say invalid phone number. Okay, which will give back a little message letting the person know, hey, that's not what I really expected for the phone number. You could do the same thing. You could use regex for an email if you wanted to, but they do have an annotation for that already. And if there's anything else you really need to have a string where you need to search for a certain pattern, you can use regex. And all you got to do is use the @pattern annotation, and that will add the regex for you. So now we've got our users. So go through and make sure you've got all the different parts together, right? All the different properties, and we'll even add the Lombok stuff. All right, so that makes so we don't have to do, like, for example, constructors and all that good stuff. So to put @data, all right, which you can do all my getters and setters, and my equals and my overrides. I'll do a no args constructor, okay, and an all args constructor, and then we'll also need to do. I like to name my tables plural, okay. Where the table is plural and then each individual row is solved as like one singular thing. All right, but remember, you can always change the name of the table in SQL by just using users. Now, the cool thing with Spring Data JPA is migrations, which we'll talk about in a little bit, okay, where we actually take this and put it into the database. But now we essentially have an entity set up. And as long as you know these annotations, you can get new entities up and running in absolutely no time. It's amazing. All right, so we've done a little more with Spring Data JPA as far as the entity is concerned, and we have a few little notes about migration so that you understand more about how that works. And then we'll go back later on and learn more about this repository stuff. All right, but for right now, if you kind of learned some of the annotations that we've used so far, they'll take you really, really, really to new heights in speed of development, speed of getting these entities out and getting your database up and running. Alright, so one thing you may have noticed that Spring Data JPA does is that it actually updates the database for us whenever we start up our Spring Boot application. So here, when I started mine up, you'll notice that it says hibernate, create table users, right? Because we just made a users table. And so it kind of tells you like what is it doing in SQL, all right, when it starts up. So let's go over to the SQL database. We're using Workbench. I'm going to refresh my database, and you'll notice that now there is a users table, and it has all the columns, right, of the different things I wanted, like username and user role. Now, a couple little small things I'll point out in a moment, but I just wanted to kind of note that we didn't actually make this table in SQL. We didn't write any queries. The Spring Data JPA just makes the table for us and adds the appropriate columns and column definitions for us. So for example, you'll notice ID is big int, email is varchar 255, etc., etc., etc. All right, so this is very convenient, of course, because it allows us to not have to spend our time having to make the columns ourselves, which really sucked back in the day. The thing is though, how does Spring do this, right? How is it actually understanding that we want to make a table? And so the reason it knows that is because here we have Spring in our application.properties file, we have spring.jpa.hibernate DDL auto update. And so what this does is basically says, hey, whenever you start Spring up, I would like for you to update the database. Now, there are other options for this one. Besides update, you could do create, you could do validate, you could do production, so development. There's a lot of different ones you can do. So you can do create, validate, there's none, and there's create, drop, create, validate, none, create, drop, and of course, update. Those are your options. All right, typically for what we're going to do update, but there is a little bit of a hiccup with update, because what update says is just update the existing tables, right? But what happens if you change something, right? So let's go to back to user. All right, so hopefully you've already run your Spring Data and it already made a users table for you. What happens if we I don't know, change something? Let's say we change this to user email. All right, so user email as opposed to just email, right? So what do you expect is going to happen? Because right now we have a table called users and it has a column called email. So is it going to take this column and update it to the new name, or what's going to happen to it? So I'm going to go ahead and rerun this, and we'll see in a moment. All right, so we notice it did add a column, user email varchar 255. That's what it says here in the console. Let's go see what it did. I'm going to go ahead and refresh this so we can take a look. And so there we have our user email. The problem is that we still have this original email here. So it didn't get rid of the old column, it just added a new column, right? And so this will be pretty confusing if you try to do this all the time. For example, it's especially in the early parts of development when you don't really necessarily are clear on what all the column names are going to be. They are subject to change. So what this would do is might create some confusion between, well, which column do I use if there's an email column and a user email column. Now, if we change the way in which Spring Data JPA does these updates, then we can try something different. What we'll do is we can try to drop all of our tables and then reload them, so that way any old changes are gone and any new changes will come in. So back in application.properties, I set the DDL auto to create as opposed to update. Now try running it yourself, you'll see what happens. It drops the existing tables and then remakes them. And so if I go back to SQL Workbench, then if I hit refresh, you'll notice that there is no more email. It goes to user email. And so what this does, it says, okay, cool. If you have a lot of tables that are changing and you don't have any data in those tables, this might be cool to do. The thing with this though is that you're dropping the tables, so if you actually had data in those tables, then they'd be gone. And so for a production scenario where you have real users with real data, this would be absolutely unacceptable. There would be no way you'll be able to do this. So typically what ends up happening is in real life, Spring Data for SQL is good to get the initial tables going, right? You get the initial schema, you set everything up and test it, but then after that, you don't necessarily allow Spring Data to actually be the thing that updates the database for you. You either do that manually with your own scripts, right? Or you will, use update and keep it from there. There are also other tools like Flyway that allow you to sort of do what are called migrations, which are beyond the scope of this course. All right, but I just want to let you to kind of drop you a note and say that the Spring Data being able to create tables for us is nice, but in a production scenario, it actually could be a little bit tricky because we don't want to lose data or accidentally drop tables, because that would be absolutely catastrophic in some cases. But for the initial setup, for getting our database started and putting our tables in there, that is perfectly fine. We can get done pretty quickly. All right, so hopefully you learned more about how Spring Data handles SQL. All right, so we have create, validate, done, create, drop, and update. Update and create are the ones people mostly use. Create drop is nice in that it will create, it works like create in that it drops the tables and creates them at the beginning, but then it also drops them when you stop the program. So if I hit stop, it would drop all the tables and get rid of them. Validate won't actually change the database at all. It'll just validate to make sure the database matches what is in, like, what your models say they should be. And so validate is actually the one you probably will use in real life quite often if they're not already using some other kind of program to keep track of the SQL schema. All right, but for an initial setup, Spring Data saves a lot of time. Now, what if we want a column to be unique? And what I mean by unique is that for every row in the column, that each value within that column, right, is unique. There's no duplicates. Now, that might make sense for email and username, because we don't want two people to have the same username, and we don't want two people to use the same email. We want everyone to register their user with a different account, and this is pretty common. Now, there's two ways to do this, and they're both fairly easy. And again, we're using annotations because that is the way Spring Boot rolls. Now, for email, you'll see we have this at column, and after nullable equals false, we'll put a comma, and we'll put unique equals true. That's it. That's all you gotta do. You can put the unique as set to true, and there you go. It's by default false, so normally you don't have to type unique equals false because that would just be redundant. Okay, but we put unique equals true. Okay, and now username and email are both unique. You can't have two duplicates in the same column. Now, if you don't like this for whatever reason, this is actually the thing that most people do. But there is another way to indicate multiple columns, or like one column or multiple columns. You could do it at the table level. So we can go to the table annotation, and after we do like the name, we can do unique constraints, and then we'll do equals, and then we'll do curly braces, and then we'll do at unique constraint, and then we'll do column names is equal to username. You can see why people don't tend to do this as much. At unique constraint, column names is equal to user email. So email. Okay, so this is another way of having unique constraints on the table level. And again, like tomato, some people like doing this because then all the unique constraints or any other constraint you might have is at the top. And so when someone looks at this, they're like, oh yeah, cool, the username and email are unique. It's very clear. Because if you have like a lot of different properties, you may get lost trying to look through all the different columns to see whether or not something's unique or not. If you put it up here, it's like, blaring bat signal that this is unique. So if that's the case, if that makes more sense to you, you can put it up here, or you can put it inside the column annotation and do it that way. But either which way, that will make email and username both unique. That means that no two people can have the same email, which is a pretty common validation for some websites. Like when you sign up for the website, you can't put in an email that's already in use. So the validation annotations are really nice, but we really haven't used Spring Data JPA for its full power in its repositories, which are really just honestly OP. So we have, for the book repository, we were able to essentially have all of our CRUD functions for free by inheriting from JPA repository, and then all we had to do was write method signatures to actually run queries against SQL. As long as we followed a certain pattern, we were able to run the query. These are called derived query methods, and derived query methods are one of the most powerful things about Spring Data JPA because we don't have to write the logic. And if you think about it, it makes sense. Like, why do I, the logic should write, the logic is just the same thing over and over again. Why do I have to write it? So how do we actually build these derived queries? So what we're going to do is we're going to create a user repository interface. All right, so remember, it's an interface and not a class. All right, it's going to extend the JPA repository, which will have a generic of user and long because the primary key of the user entity is a long. And so we're also going to have to inherit this. Okay, it'll come to its senses in a moment. My IntelliJ takes a while sometimes. All right, now, just to let you know, we're going to do where essentially each entity, like user or book, will have its own repository, its own service, and its own controller. Now, that is not the only way to organize your backend API. You could have what's called domains. And what a domain is essentially a business domain. So you might have a human resources controller, a user management controller, and those controllers might mix and match what services and by extension repos that they use. That is a common way of doing things, but this is also another common way of doing things where it's all done by entity, okay, so as opposed to like grouping them. All right, so let's go ahead and start doing our derived queries. And all we have to do here is essentially write them out. Remember, we get all the CRUD functions for free. We don't have to do anything. So let's talk about finding a user by their email. Now, if we go back to user, we actually made the email unique. So when I want to find a user, I want to find a unique user by an email. If we think about it, there's two results to this query. Either A, I find the user with said email, or B, I don't. So when we write our signature, we have to kind of think about what kind of data we expect to get back from the query. I expect to get back a single user or nothing. So optional, okay, it makes a lot of sense here. So I'm going to optional the user, all right? And then here we go, import the user. Thank you very much. All right, so an optional the user because I can find the user by their email or maybe they're not there. Now, how do we actually write the derived query? There's some rules. It can start with a few different phrases, all right? And these phrases are just pre-built. That's just the way it is. There's nothing to do about that. You just need to learn them. All right, obviously find by, which is the one we've been using. There is counts by, exists by, query by, get by, and read by. Now the first thing, read by, there we go. And the first three are probably the most useful. I mean, I haven't taken a survey or anything, but just in my own personal experience, the first three are the ones I use the most. Find by is probably number one. And when you write your derived query, it has to start with one of these, all right? So it'll be like find by something, it counts by something. All right, so we chose find by, that's our first one. Okay, cool, we wanted to do find by. Then we need to say which property of the entity do we want to query on. Remember, our entity in this case is user, and its properties are here, so you need to pick which one we want to query by. We want to do email. Okay, cool, so find by email. All right, and then that's really all we have to do. Then we can do parentheses, and we need to pass in the email, the variable that represents the email we want to find the user by. That's it. We're done. That's why Spring Data JPA is a beast, because we can write our queries without having to actually write any implementation, and it's great. All right, as long as we follow the rules of how to write the query, right, the right order, we can do things. Now, this is also nice in that email is unique, so I only expect to find one user. One thing to learn about find by, one thing to note, is that let's say, for example, I wanted to find by a user role, for example, right? That would be different because what find by would do is it would find the first user with that role and return them to you, but it does not necessarily mean there's not more than one. This makes sense for our case because email is going to be something that is unique to each user. So just to let you know, again, find by will find you the first thing that matches the query. If there's more than one and you have like optional as opposed to list, it will just give you the first one that it finds. All right, let's try to find something by the email and their username. So still gonna be optional user because it's only gonna be one. We want find by as our first thing. Email, and now I have two properties. I want to find them by their email, and I also want to find them by their username together. Okay, so it has to match both the username and the email that I give it. So find by email and username. String email, string username. So a couple details here. First off, I use and in between the properties to say it needs to match the email and it needs to match the username. Okay. There's also or. Okay, there's an or keyword here as well that we can use. So you could choose and, or you could choose or. You can have multiple properties you're querying by. So this is where we're querying by two properties, email and username. If we had 3, then there'd be 3. If there'd be 10, then there's 10. Please don't do 10. But, I mean, you could, right? There's nothing really stopping you from doing that. The order of the parameters does matter. Okay, the first one's going to be email because the first parameter in the name is email. The second will be username because the second parameter here in the name is username. Okay, if you switch them, even if you were to switch the variable names, it would still treat the first one as the email because it's the first thing that comes through. Okay, also keep in mind that this is going to be you have to keep an idea of what the data type is, it's not going to tell you if you use the wrong data type. So for example, username is a string, and so is the email. But if I say double username, you won't know until the query runs that it fails. All right, so you do need to make certain that the data types match. All right, and that's on you, but that's also super easy. There should be nothing to it. All right, so now we've learned how to start writing a derived query. We're going to definitely go into this more, but the one we're going to concentrate on in this course is find by, because that's the one you're going to use like 9 times out of 10, honestly. Although accounts by and exists by do deserve honorable mentions because they are champs. Okay, so you write the query by first figuring out what kind of data you expect to get back. In this case, I expect to get back a single user or nothing, so I use optional of a user. You then start with find by, or you basically pick one of these to start with, and then you'll do a property. If you have more than one property, you need to concatenate each property with an and or an or, depending on what the situation requires. You then put parameters that are necessary in the parentheses, and they need to match the order that they are written in the method signature, so that does matter. All right, so this is the basics of writing a derived query. So after this, we'll learn some more details about how to do something a little more complicated than this. All right, before we move on with creating more derived queries, we're going to go back to the user entity and add a new property that we're going to use for the other examples. And it's going to be called address. So private string address. All right, cool. And then we can use the column annotation. Now, just a little note about the column annotation. It's not necessary 100% because if you were to just put private string address by itself, Spring Data will still regard this as a column in the database. So this doesn't mean like, hey, like, you know, this is supposed to be in the database. It will do that automatically. It's just good form to use this because later on you may want to, for example, make it not nullable, or there's other, you know what I'm saying, or unique, etc. So it just kind of depends on what you want to do. We're going to go ahead and just have column private string address because we're going to use this for our example. So go ahead and add that to your user entity. Let's head back to the user repository. All right, and let's do more with our derived queries because there's so much more you can do. All right, so let's say, for example, I want to find all users based on an address. Now, an address is usually a longer string, like 1234 Broadway Street. And so maybe, you know, you're looking for part of the address, right? So it's like, I want to find an address that contains a certain string within it. So for example, if your address for 1234 Broadway Street, and I want to know all of our users who live on Broadway Street, I might just look up Broadway Street and then get all the addresses that contain that specific string. We can do that. So first things first, if we're searching for users, right, it's plural, right? Because I could put in Broadway Street and get back 10 people, no problem. I might not get back anybody, but I could get back multiple people. So in this case, it's going to be a list of users because it could be more than one. All right, so since it's a list of users, I'm going to go ahead and import that, the first one, Java util. Then I could do my derived query. So find by is going to be first. I want to find users. And then I'm going to do address because that is the property that I am doing the query on. And then containing. And then we'll do string keyword. Okay. Notice how this doesn't necessarily have to match like address, right? I didn't put address in here, I just put keyword. The reason being is that when behind the scenes, when Spring Data JPA actually builds the SQL query, it will know it's looking for the address column, and then it will just derive the fact that, oh, you gave me a variable that must therefore be the address. All right, so what does this one do, find by address containing? What find by address containing does is, well, actually, I think it's fairly straightforward. It will look for an address that contains, okay, the following, the string, basically. So you can think of this like in SQL. So you can think of this like, the like keyword in SQL, all right? That makes it easier. More specifically, it's sort of like when you use the wildcard, okay, before and after. So it's looking for anywhere in the string does it have the keyword. So if I'm looking for people who live on Broadway Street, that's fine because like it's in the middle of the string. So for example, just if I'm looking for people who live on Broadway Street or 1235 Broadway Street, you'll notice that Broadway, I can look up Broadway, right? And then I can look that up and I would get all these multiple users even though Broadway would be in the middle of the string. So that's fine. Let's say, of course, you want to do ignoring case because if we're dealing with user inputted data, we do want to normalize the data, meaning we want to ignore case because people type in things all screwy all the time. So we could, instead of doing find by address containing, I'm going to go ahead and comment this one out to do the new one. We can do list of user because it's still more than one user, and find by address containing ignore case string keyword. The difference between the two is that this one, well, ignores case. It doesn't matter if it's uppercase or lowercase. That's fine. You get to, it will still pass muster. All right, this ignore case is actually very, 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 very useful, honestly, in real life, especially when we're dealing with user input. You remember, user input could be whatever the user puts in, and God knows what they put in sometimes. Now, other things you can do besides containing, all right? So other things besides containing are starting with, ending with, okay, and like. Okay, so I think starting with and ending with make perfect sense. So it either starts with something or ends with something. So for example, if I wanted to find all the addresses that start with 1, 2, 3, 4, I could use starting with or ending with. All right, so let me put containing in this list, and I'll put it up top. All right, that way you kind of know your choices here. All right, so you have starting with, so find by address, containing, or ending with, or starting with, or like. All right, and like is actually pretty much the same as what we've been doing. It's containing. So these are just keywords you can just use however you want to. So this is great for when, again, you're working with like a string and you're trying to find a pattern within the string, be it wherever position it is, and then you can go ahead and do that. Now, again, if you're trying to find, if you're dealing with a large string, so for example, if you were trying to, if you had like a book, and again, you probably wouldn't do this, but if you had like a large block of text in SQL, and again, this actually does happen sometimes. Some people do put large blocks of text in SQL. Then this might not be the world's greatest, like the fastest query, because it would have to search through the whole string to find the pattern. But for things like addresses, this is perfectly fine to do. Just a small little note in terms of performance, all right, in case you're thinking about, well, how would this work for like big data? It would still have the same, you would still have to tweak it on the SQL end or use a different solution than SQL in order to really handle that kind of thing. But for like addresses, this works perfectly fine. All right, to review, after you do the find by and then the property, you can do containing, starting with, ending with, or like, if you're doing some sort of like looking for a pattern within a string. You also can have ignore case afterward in case you would like to ignore whether it's capitalized or lowercase. This is especially helpful when dealing with user input. All right, so now we're able to build more, shall we say, complex derived queries because, like I said, there's a lot of different queries we might need. So far in our repository, besides the CRUD functions, we can find the user by its email, find a user by their email and username, and then we also can find an a user by the address. We don't have to have the full address. We just have to have part of it, and we can search for it, and then also ignore the case in case the user puts in something weird. All right, so now let's continue learning more about the different things we can write in a derived query. So let's go back to the user, and we're going to add another column for age. Okay, so let's say we record how old the users are. Okay, so I'm going to do int and then age. All right, so like maybe for example, for some websites, like there's an age restriction, like you have to be like 12 or over or something like that, or have a certain age to do certain things. All right, so maybe we record the age of our users. All right, now with age is a number, and so maybe we want to find all of our users who are of a certain age for like advertising purposes, right? Like I want to find everybody over a certain age. So we can work with numbers in our derived query, and it's actually very simple. So if we search for users that are over a certain age, we are probably going to get more than one user, so having a list of users as the return type makes sense. We still use find by, and then we still use age, right? Because we still have to do find by as like the first thing. Again, we have the other options, but we're going to do find by for right now. Then the property we like to do the query on, and then we have an extra part here, which is just greater than. We'll do integer, age. Cool. So there is greater than and less than. So again, if you want to do less than a certain age, you could do user find by age less than integer age. All right, so that works as well. All right, so greater than, less than. Now, if you want to get in a certain range, so for example, we'd like to find everyone between the age of 35 and 50. All right, so let's say you could use a combination of these things, but more importantly, you can use the between. So we can do find by age between. Okay, integer start age, integer and age. All right, so greater than, less than, and between will be what you would use in this case for numbers. All right, so if you want to query based on that. Now you may have noticed that I use the integer class as opposed to the primitive int. You can use primitives here, so if you could write int age, there's nothing wrong with that. The thing is with the class is that it handles null better. So like for example, this is a wrapper class for the primitive integer, right? So therefore, because it's a class, it could be null. So you would use this in cases where there's a chance that it's a null value within the database. In this case, we're just going to say a part of registration is gathering the user's age, so we are pretty clear that users that will not be null, will have some kind of value in there. And so using the class is actually like fine, or we can use the primitive. The difference is really small. Honestly speaking, it just basically has to do with whether or not you expect it to be null, because remember, the primitive is not nullable, whereas classes are. Okay, you do save a little bit in performance, but like the performance gain is almost negligible, honestly, in reality. So I tend to just use the wrapper classes for things like integer. But again, if you don't want to, you can use the primitive. It's no big deal. All right, so when working with numbers and querying based on numbers, we have the greater than, less than, and between options to allow us to pick ranges of numbers. All right, so now we're able to query users based on their age, however we'd like to do that. So as you can see, like there's so much time we're saving by writing the derived queries, because we don't have to actually write any of the logic. We just do everything declaratively and just say this is what we want to have happen, and then Spring Data JPA will go ahead and do that for us. So this is really powerful stuff. All right, let's finally do some business logic. All right, so we're going to create a service, all right, for our user. Now notice I emptied out the repository of all of the example queries we did before, because we're not going to end up using them all. We're actually going to craft our queries based on the needs of the business. All right, so let's go ahead and make a user service, all right, which is a regular class. Okay, and if you remember, we're going to annotate the class with the service annotation. Now we're maybe wondering, what is the point of this? The service annotation is actually a little bit of syntactic sugar. What I mean by that is that you don't necessarily have to use the service annotation. If you want the service just to be something that can be injected into other classes, you could just use @component. Okay, @component is a general, hey, this class goes in the dependency injection container, so keep track of it, please. And so why do we have service then if it doesn't really impart any special powers on the class? So when we mark something with service, it's injectable, but so is a component. What does this do magically for us? It doesn't do anything magical for us. What this does is it's more semantic. What I mean by that is it is clear what this class's role in the program is supposed to be. Services are there for business logic. They're not there for direct data retrieval or direct data manipulation, and they're not there to take in requests and return responses. They kind of lie in the middle. They do all of the work that you can't just do with a request, or you can't just do with data retrieval. It's business logic. It is decisions and the rules that govern how the business works. Because remember, at the end of the day, you are writing, the reason you have a job is because you're writing a program that solves a problem, usually for a business. Again, maybe you're doing a personal project, I understand that. But at the end of the day, you are writing software that serves some kind of purpose. And there's going to be rules for how that software works. Those rules, if they don't go into, this is how I retrieve data, this is how I directly manipulate data, and they don't go into, hey, I received a request and here's the proper response, it lies in the middle, and then that's where you would put it in the service. So all the business logic, how the business operates, okay, all the rules for how the business operates go inside the service. And that is what you are communicating by putting the service annotation, saying that that is the role that this class will play. So I know just looking at this that this is going to be business logic related to the user. This saves a lot of time, because especially if you're working with a team, because everyone will know the role that every class is supposed to play. So if there's a bug, I know where to go. So for example, if the data is not coming back, like if I'm trying to delete something and it's not deleting, the first thing I'm going to look at is the book repository. Because direct deletion happens here, because that's where the data manipulation happens. If a business logic problem comes up, then I would look here in the service. Now, again, you may still be fuzzy on what the word business logic still means. So let me give you an example. So let's say, for example, we had to have a report that someone at the business wants to have made. Let's say we're some sort of like company that's, again, we're selling books too, right? We're selling stuff. We have books in our application. And so maybe we have users that sign up for application, and someone in the business would like to know how old are our users and where do they live. Or they want to specifically have like an age range. They want to know like, hey, do we have like a lot of young users living in state X or state Y, or are they older? They want to be able to play around with this report and be able to get the data the way they want to look at it. So let's make a method in our user service that will do that. Public string, and then we're going to do generate age state report. All right, so it's essentially just going to be a string, okay, and we probably wouldn't necessarily do this in reality. Typically in reality, you might actually have this generate an Excel file or maybe like some sort of like PDF document, but we don't want to get into all that. I'm just going to use a string just to make this example simpler. Now, we'll need to know the age range. So we're going to do the start age and the end age of the users that they're looking for, plus the state. Now, we're actually going to have to amend the user entity and add a state here. So at column private string state. And this is like a state like Michigan or Maine or wherever, right? You'll say, Jonathan, we have address. It's going to be a little bit better to have just the state since we're querying by this and to have an address that we have to search through. Plus, we're like more assured that this is going to be an actual state. Could you use an enum for this? Absolutely. All right, but we're going to keep it simple and just use a string for right now. Okay, cool. So now you're saying, I would like to know our users beginning in this age range, right, that live in a certain state. Well, now we know that we can actually build that query in the repository. So remember, the repository's job is just to go grab data. It has absolutely like no like meaning to it. It's just basically like, okay, cool, I just want to go grab the data. I don't know why I'm grabbing the data. You just told me to go do it. All right, we need a list of users. We know it's going to return a list of user. And I'm going to go ahead and import the list. Cool. And then we're going to use our derived query. I want to find by, and now this is going to be multiple things, right? Because I need age and state. But we can build a query like that. So I want you to pause the video and think about what would you actually write here. Like, what do you think the derived query is going to be if I wanted to get it? If I want to do a query that will get users between two ages and that they're live in a certain state. Pause the video and think about it. All right, so we'll do find by age between. All right, and then we'll do and state ignore case. Mainly because I don't know if the report is going to give me the state in the proper format. Again, this would be a case for using an enum, but we're going to keep it nice and simple. So find by age between and state ignore case. So we'll do integer start age, integer end age, and then string state. Perfect. All right, the repository is just going to go ahead and do the query. All right, again, you may be thinking to yourself, well, you know, what if we got all the users and in the service we loop through the users? My biggest piece of advice to you is let SQL do the work for you. What I mean by that is don't try to just grab all the data from SQL and then in Java filter through everything. Your query you should be asking SQL for the data that you want. SQL is designed to work with large data sets. It is designed to query efficiently. Let SQL be SQL. Let SQL do what SQL does best. All right, and then we take the data, and then we can take the data and do whatever we want with it. But let SQL handle that part. So here's the query. All right, so we go back to this service. We know we're going to need the repository, so we're going to go ahead and auto wire it. Private user repository. All right, that auto wire, if you remember, is going to go ahead and inject the user repository into the user service so that we can make use of this. All right, so now let's use it. List of users in range is equal to user repository dot find by age between state ignore case. And now all we got to do is put the data where it should go. So there we go. Cool. I'll have to import the user. I'll make a little bit more room here. I have to import the user. Again, this second one's IntelliJ catches up with me. All right, and then I can I can make a string out of this. Again, in real life, you would probably maybe like take the users and format them in a PDF or an Excel file or whatever you want. All right, so we're gonna do a string just because that's gonna be the easiest. I have to get all into like PDFs and stuff like that. But maybe like that would be something you could do here, and that would be definitely good business logic. All right, let me go ahead and import this. Bam. All right, and then also import the list. Cool. All right, string report is equal to users in range. I'm going to stream them. Okay, if you're not sure on streams, that's fine. If you go to the advanced Java course, there is a whole section on there. If you have a subscription, then you can just go ahead and go and look. But I'm just going to explain myself as I go. I'm going to take each user and map them. I'm going to do string.format. ID, let's do %d. And then I'm just going to, I already wrote this out, so I'm just going to go ahead and put this whole string in there. You can, if you're following along, you can just go ahead and copy this, because like I said, I don't want to take up too much time having to do all this. Okay, cool. All right, there we go. User dot get email. There we go. All right, so I'm going to map each user to a string, and then just do collector. Where are we at? So here we go. Dot collect. Okay. Cool, and then we'll do collectors dot joining, and then -n. All right, and so where are you angry at? Oh, one too many parentheses. Here we go. All right, cool. So again, you would probably in real life, like, you know, make some sort of report. And again, that would be done on the back end, all right? Or maybe you have like a third party you send the data to and they make a PDF for you. It depends. All right, and then we're going to return. So first off, if the report is empty, meaning that there were no users back, we're going to basically say no users found. Okay, otherwise we'll get back the report. This is a pretty good example of what business logic might look like, right? We make a query, all right, and let SQL do its job, and then we take that data and we do something else with it that the repository can't do. The repository cannot take the users and format them into a string. It's not its job. So that's what we can do here for our report, and then we just return it. Turning things into Excel files, applying discounts, filtering data. So basically, like, business logic essentially is a very broad thing because it depends on what you need. Okay, but decision making based on data usually occurs in the business area, right? That's what we mean by business logic. Like, what decision making does the business do? So here it's like, okay, cool, you've given me the data, right, which is what the repository does, and then here's what I'm going to do with the data that's like a layer above that, and then from there we go. So this is a good example of business logic. All right, so we learned about the service annotation. Again, it doesn't do anything magical. It just makes this service. It's no different than @component as far as dependency injection. It just classifies. It just says to us and other devs, hey, this is a business logic class. This has a service. That's what it should be regarded as. Okay. I also have an example of what business logic might look like. All right, so we're doing more than just grabbing data. All right, so I know that previously when we did the book service, all of these were just essentially like a layer above the repository, but they didn't do anything special. They just did what the repository does. So at the end of the day, right, we could have skipped the book service. I just wanted to show you the example. But here, right, this is beyond what the repository does. Okay, so this is formatting the data into another format that we might want, in which case that is something the business may need. All right, so reports are things that might fall into business logic, applying discounts, taxes, things like that. Okay, anything special kind of logic would go in this layer. All right, so we already learned about how to use data annotations in our entities to help with validation. So for example, the user has things like not null, and set in a column to like nullable equals false, size, things like this are how we validate and make certain incoming information is how we expect. Now, another strategy we use typically for APIs is actually to separate the request, the shape of the data in the request versus the shape of the data in the database. Oh, you're like, what are you talking about, Jonathan? Typically, you have like models, right? Book, user, whatever you have. And they will have all their properties, etc., etc. But one thing that is pretty common to do is have what's called a data transfer object. What I could do is first demonstrate to you how that works. So I'm going to do a package. I'm going to call it DTO. All right. The data transfer objects are the objects that are going to come in or be sent to the client. So they represent the data that's coming in and out of our API. They're separate from, but related to, the actual entities that exist in the database. So we're basically creating, right, two different layers. There's two different objects. One that directly represents the data coming in from the client and being returned to the client. And we have a separate model for data at rest in the database. The reason for having this separation is a couple reasons here. The first is sometimes in the database you have pieces of information you don't want known to the client. You want them to stay in the database. They're important for the database and the data layer to know these things, but they're not important for the client to know. Okay, so I need to know basis. Now, that would make things very, very difficult if we only had the entity to work with, because we'd have to somehow pick and choose which properties we want to have be revealed to the client. If we have a separate object, then it's easy, right? We just basically say we're going to use a data transfer object. It has these properties. I'm okay with these properties being shown to the client. No problem. Also, sometimes we want information from the client, but we have to transform it or do something to it. And so we don't want that showing up in the database necessarily, but we do want it from the client's request. So by separating the two, we actually give ourselves a little bit of flexibility. Yes, it adds more complication. It would be a lot easier if we did what we did in the book controller and just return the book, right? So in the book controller, we don't make use of data transfer objects. We just take the entity book and return it directly through the different endpoints that we have, which is, again, fine. I'm not knocking this. But I wanted to also show you another practice that people do, in which case, instead of directly returning the entity book, we're going to create a data transfer object that will be passed back to the client. I'm also going to show you when you might want to use these sorts of things. So what I want you to do is I want you to create a package called DTO, and we're going to make user DTO. Okay, user data transfer object. Now note, this is not going to be an entity that exists in the database, right? This is not going to be a table. This object, so therefore, does not need the entity annotation at all, because it will not exist in the database. Okay, this is going to represent what we expect to give back as a user. Now, here we can be real fine-grained with this. So, for example, sometimes people have DTOs for different operations. They may have a create user DTO that will be for specifically creating a user, whereas we'll have like a user DTO for getting back a user. We're not going to be that fine-grained, but I did want to kind of show you that like that is actually a thing that sometimes people do, because maybe different requests have different pieces of information. Remember, this is supposed to represent the request or response to the client. So this is the client-facing part. The client's going to actually see our DTOs. If we do this right, they won't ever see the user as it exists in our database. It will always have something changed to it. All right, so go ahead. We're going to go into a user DTO. We're not going to be as super fine-grained as having a create user DTO, update user DTO. Again, that's possible if you want to be that fine-grained with each request. But let's start with the user DTO, and basically we have to go through and say, okay, what about the user do I want to have exposed to the client? All right, so for example, the username and email might be things that I want to have exposed to the client. Okay, so we might have to, all we have to do then is essentially do private, and then we'll just bring over the stuff from the user that we want. So I'm just going to go ahead and be like the username, okay, and then the email, maybe the role. That would make sense. The front end may need to know that, what role the user is. What else might they need? The phone number, like for example, we're showing the user profile, then we would show the phone number, the address, the age, and the state. All right, so we might go through here. And notice I'm not using the annotations like column and stuff, because that's not necessary, because the DTO does not exist in the database. Okay, then there is the state. All right, and there we go. All right, I just brought over the stuff that I wanted to bring over. Now you may be thinking to me, well, Jonathan, this is just a copy of the user. Like, what is the point of this, right? Actually, we can do ID too while we're at it. I didn't do ID already, missed ID. But again, so your point is still valid, right? We just are copying over stuff from the original. Like, why are we, like, what's the point of doing this? Well, let's add one more thing to the user. I think this will bring the idea home. Let's say the user in the database has a password. Okay, we're not going to do the whole, like, encrypting the password or anything like that, but picture that there's a column in the database that has the user's password. That's pretty common. I don't want their password being kicked up to the client. I don't want someone using my API to see the password of the user, even if it is an encrypted format. I don't want this exposed to the client at all. So all I have to do is just simply not include it here. So you see how that works? So essentially any information you don't want to go up to the client can still exist on the user entity because this is what's going to be in the database. And this is only ever going to be, this whole class right here is only ever going to be used in the back end. The client will never ever see it or ever touch it. So the client, the person using the API, is only ever going to interact with this class, ever. So since that is the case, then I feel a lot better knowing that certain secrets and certain pieces of information are not going to be exposed to the client. That's the power of using the data transfer object pattern. Again, it does add a bit of complexity, which I'll show you in a bit, but I wanted to first showcase like why it is we might do something like this, all right? So for example, passwords would be an excellent example of when we don't want to, I'll put column on here, when we don't want things exposed to the client. There could be a bunch of other examples, but again, the database, the way data exists in the table is not always the way you want data shown to the client. As long as you understand that basic concept, I think data transfer objects, or DTOs, should be very clear. So now we've created a user DTO. In the next lesson, we're actually going to use it, all right, to do something. All right, let's continue our discussions of DTOs. And also, this will be a good jumping board to talk more about business logic. All right, let's have a DTO that will represent someone trying to register a user. Okay, we can call it user registration DTO, something like this. All right, and so you can have a DTO for certain actions. This is actually quite common because not all requests are going to be the same, right? This is a request that's going to come in and it's for registering a user, right? So here we would only have the properties of things we need to create a new user. So for example, we may need the username. So the person will pick a username, private string username. And they have to have an email, private string email, and an age, private integer age. Let's do phone number and state as well. Private string phone number, private string state. All right, so let's say that these are the things that someone puts in when they register. Okay. Do we put annotations on these? Okay, so how are we going to make certain that we properly validate the incoming information? Because we do have validation on the actual entity, the user as it exists in the database. But do we need all of these things? Well, first off, some of these annotations are only for the database. For example, at column. Okay, so the column is for, well, creating a column in SQL, right? We don't need the at ID because, again, that's for setting the primary key in SQL. So those sorts of annotations we don't need. But we can use the validation annotations like not null, for example, okay, which makes perfect sense because, well, the username shouldn't be null and the email shouldn't be null. Okay, and let's go ahead and say the age shouldn't be null, and let's say the state shouldn't be null. Maybe they give us a phone number, and maybe they don't. All right, so that could be something that they may or may leave out the phone number, but everything else they need to give us. All right, and we can even use our size. We can say the username needs to be of a certain size. I think I picked, 8 and 20. We'll use that from here. All right, so I'll give you a second. You can pause the screen to catch up. All right, we've made our user registration DTO. As you see, we use these validation, annotations. For phone number, we can even use the one we used from the model for the phone number at pattern. Okay, so it's pretty common to use validation annotations with your DTOs, but there's no need to use the annotations that have to deal with the database because there is no database because the DTO is not represented as a table in the database. All right, so now I have a DTO that represents someone wanting to create a user. And we'll go ahead and use Lombok to finish up a no hours constructor, all hours constructor, and data. All right, so that way we don't have to do all that nonsense with writing all the getters and setters, although it's not that big of a deal with IntelliJ. All right, let's actually use this for a second. All right, so if you remember, the user entity is going to have a full suite of files. We have the user repository, the user service, and let's do the user controller. Okay, there we go. We're going to make this a REST controller. Okay, and you remember that from the book controller. Let me scroll the way up so you can remember we had this REST controller to say, hey, this is a controller, and then we'll do at request mapping. And we'll do /API/users. All right, so if you remember this from our controller section, we're now saying this class is a controller, and if you'd like to access it, you need to go to /API/users, much in the same way that this is /API/books. All right, now that we have the controller, let's go to the service for a second and add some business logic to register a user. All right, so we're going to basically say a registration. Okay, which we can use the service, and then we'll basically return a user once it's registered. So we can do public user register user, and we can actually use the DTO here. So let's go ahead and use it. So we'll use our DTO here. We'll do user registration DTO, and we'll say user DTO. Okay, so if this is a method that will return our user, should the user be created properly. If there is a problem, then we can go from there. So let's say, for example, that you have to be a certain age to register. So what we can do is we can go ahead and have an if statement. Like, let's say user must be over the age of, I don't know, 12 to register. Okay, like maybe it's a site that's like, you know what I'm saying, it's they gotta be a certain age. All right, or let's just say 18 maybe. Like it's like a e-commerce site, they got a credit card, we wanna make certain the kid, we're not letting in small children. So we can do if user DTO dot, and we can do get age, okay, is less than 18. So this is kind of business logic, right? I'm checking to see the age of the incoming user. If they are too young, then we can say user must be at least 18 years old. Okay, we can throw an exception, okay? In which case it'll be like, hey, I don't know what you mean, let's throw an exception, like it's unhandled. We don't know if this is going to crash or not. So what we can do is we can just add it to the method method signature saying that this throws an exception. Later on, I'll show you another way of handling this. All right, cool. So they're over 18. Awesome. I'm going to create a user manually, and then we're just going to set everything. So user.set username is the user DTO.get username. So you see, I'm just basically creating the entity, the user, and then bringing over or mapping all of the other set email. Okay, so I'm just bringing over all the other information. Okay, so set age, or set address, user DTO dot get address. Oh, I forgot the address on the DTO. I probably did. The user registration. Yeah, I forgot the address, so we'll just skip that. That's fine. You get the idea. I don't want to make this too long. Emails, so we'll do state. Okay, etc., etc. All right, and then we will return user repository dot save user. All right, did I get everything? I skipped some stuff, so let's go over it. Email, age, phone number, state. Email, age, I need age and phone number. So let's do user.set age, user DTO.get age, user.set phone number state. Yep, set state phone number. We need phone number. The setter for phone number. Thank you, IntelliSense. Okay, and then on the entity, we said we don't necessarily have an address, don't necessarily have a state or a password. Okay, cool. And then what we'll do is we'll set the role Oops, let me go back to the service. We'll set the role to just default. All right, so set user role dot user. All right, so as you can see, by separating the DTO and the base like entity in the database, I'm able to do things like this. I can grab the information from the client that I want, but then I can still do things like setting the default user role to just user. That way, the client doesn't get to tell me what the role is, right? I get to kind of control it to make certain that it's the role it should be. New users should have the role of user. I set that in this service layer, and so therefore it is predictable. It's what I expect it to be. Okay, then this will get saved, right? And then that'll be it. So let's go ahead and go to the controller. The next lesson we'll take this register user. All right, we'll use the DTO in the controller, and then we'll try to test it out and see if we can get a valid user into our system. All right, now that we've got the service going, we're going to actually create a controller endpoint, and then we're going to test it. Alright, so we will of course need the service, so let's go ahead and auto wire up the service. Private user service, right? So there we go. Alright, and then we'll have to of course import this. Nice. And then typically we're going to be asking for information from the client, so that would be a post. Okay, and we're going to do /register as the endpoint. So they'll have to do a post to /API/users/register to register a user. I think that makes a lot of sense. So we're going to return a response entity. We'll keep it simple. We'll do a string because I don't want, right now the service returns the user directly from the database, and I may not want to do that. So I want to return a string for right now. We can create a DTO for the user, right? We can use the user DTO in a bit. But let's just return a string for right now, letting them know, hey, everything went hunky-dory. Register user is the name of the method, and we'll get the request body and use our DTO, user registration DTO. Now, the cool thing we can do here is because we have annotations on the DTO, so if I go back to here, I have these like annotations to check to see, hey, is it null? Does it match this regex? Okay, things like that. We can actually add another annotation in front of here called valid. And that will check to make certain that, well, is it valid according to our annotations? If it's not valid, then what will end up happening is we'll get basically send back to the client, okay, an error with all the validation errors that they put in there, which is kind of nice from the client's perspective because here's the thing. Remember, the client doesn't actually know our registration rules. They could be, your API isn't always going to be used by you. It's maybe used by other people, and they can't read your mind. They don't necessarily know what is or isn't things that you will require them to have. So having a response that says, hey, here's what you got wrong is really nice. And using this add valid annotation is also very nice. So we're going to do a try catch because this could throw an exception. All right, and then we're going to attempt to try user service dot register user passing in the DTO. Okay, cool. There we go. And then if it's successful, we'll return a new response entity. User registered successfully with an HTTP status of, I guess, created would make sense here because we created the user. Spell that correctly. There we go. Otherwise, we'll return a new response entity of just letting them know the error message, although, and then just tell them bad request. Okay, like, too bad, so sad. Sorry we couldn't register the user for you. All right, so you'll notice here that in the controller, only thing we use request body like we did before, right, to get the body of the request because they're going to send us a bunch of information. We also use the at valid annotation to check and see like, hey, is the thing valid? That way we can check. We can literally check to see if certain things are null or if certain things follow a pattern. All right, let's fire up Spring. I've already got it going, so let's go ahead and fire it up and let's try it in Postman. All right, it says started, so let's go to Postman. Let's try out this request. All right, so we're going to do, no, I don't want that Postman, go away. http://localhost port 8080/API/user/register. And we're going to do a post because we're sending information in the body of the request, which will be JSON. And so we're going to write some JSON here. I'll do that real quick. All right, I just made some JSON, username, email, age, phone number, and state. All right, I just put some dummy data in. You can do it as well. I put a phone number, state California, usernames John Doe, and email. All right, now there may be an error here. We'll see what happens. We're going to hit the post button and just let it go. 201 created, perfect. All right, so our user was registered successfully. Let's go see what that looks like in the database. Okay, so in Workbench, I've selected all from users, and you'll notice that we've got, first off, the user role, which, as you notice, was not in the post, but we set the user role to the default, and then all the rest of the data, right, is there. Address is nothing, and password's nothing. All right, so it looks like we were able to successfully post. You see it has an ID and everything. All right, but what happens if like something's wrong? All right, let's say for example something that it's supposed to have a let's do an email, right? Let's actually blank out the email, and let's try and see what happens. All right, and so we get an error. We got a 400 bad request. All right, and then duplicate entry for key. Now there's a nicer way of having a little bit nicer error messages than this, but you'll notice that we couldn't insert this into the table because the email was blank. All right, and so you'll notice that if I come back here and try this query again, right, we don't have any bad data, okay? So that is kind of the point of validation. We don't want bad data getting into here. If stuff is nullable, then it's nullable, but for things that are not nullable, we don't want them to be null here. So what the validation does is stops it before it ever gets to the database, or when it gets to the database, it's like, no, sorry, bro, you can't do that. So you'll have to, of course, make sure everything's correct. So also another thing was that this is not unique. Right, we already have a user with this username. So you'll see here we've got actually quite a few things that are wrong with this. But again, we can have a nicer error message than this. I'll show you how to do that. But hopefully now you kind of understand the power of DTOs, okay, data transfer objects. We're able to essentially separate out the requests and the outgoing data and incoming data from the representation in the database. And you can get as fine-grained with them as you'd like. So for example, we actually made a user registration DTO, which represents registering a new user, which might be different than returning a user and looking at the information there, or updating a user. And so having this level of fine-grained control on what the client can do actually is very helpful, because that lets the client know like what boundaries they're supposed to work in, and also can help us predict what data is going to be coming in, so that when we work with it in the back end, we also know what to do with it. Now, in the rest of this unit, I'll show you some other things you can do to kind of streamline things. First off, for example, manually doing the transfer from the user registration DTO to the regular user is kind of a drag if you have to do this for multiple areas. Like our user service only has 2 methods, but if I have to do this for like 10 methods, that may be a real drag. So I'll show you what some people do with that. Also, it would help with this because we're returning the actual user up to the front. We're not doing anything with it, but like we would also want to have the user be transferred to the DTO. So I'll show you what some people do in order to solve this repetition problem. But again, hopefully you got the idea of the power of using a data transfer object in your API. Now, having to manually map from DTO to entity or from entity to DTO, it can be kind of a drag, especially if you have to do it in multiple places. So maybe for user registration it'd be okay because there would only be one endpoint that used the user registration DTO, but to go from the user, right, to the user DTO would be something you might do multiple times in multiple endpoints or multiple different places in our application. So manually mapping like this is okay, but there are better options. So the first one, what we're going to look at first is making our own mapper. So we have a class that essentially exists to map the DTO to however we want to go. So let's go ahead and make a new package, and we'll call it mapper. So we'll put mappers. All right, this is one approach some people take because they like to manually map from the DTO to the entity and vice versa. So we're going to make a user mapper, and then we're going to annotate it with the component annotation. So this is something that's going to be injectable. So remember, if we put the @component on a class, that means, hey, Mr. DI container, Mr. Dependency Injection Container, this is a thing you need to keep track of. So Spring Boot will know what a user mapper is, and we'll be able to inject that into our service. So what do we do from here? Well, we're gonna make a method that will take in a user registration DTO and turn it into a user. So we'll do public, it'll return a user, we'll call this to entity, and we'll say user registration DTO. Okay, it wants us to import this, that's awesome, go ahead. And here is just the mapping logic. So if the DTO is null, which again, it could be null because it's a class, so we'll return null, saying like, nah bro, you didn't actually give me something to map. After that, honestly, we can just take our logic that we had in the thing here and bring it over. Okay. So I'll just call these all DTO. Oh no, alright, so I'll just go ahead and go through. I know you can do a faster replace, but this is fine. Cool, so there we go, and then afterwards we will just return the user, alright? And so I'll put all my mapping logic here, and so instead of doing all that stuff here, instead what we would do is we would inject, we'll auto-wire the user mapper, private user mapper, and then we'll just go ahead and use it here. Okay, that way instead of having to okay, so it'll be injected for us. So we can say the user is equal to user mapper dot to entity, and we'll put the user DTO into here. And see how this, like, it makes the logic inside the service, okay, a little bit cleaner by having like basically a helper. Okay, the user mapper is sort of like helping the service do its job by mapping the user registration DTO to a user for us. That makes this a lot cleaner to read, and so the person looking at this, they don't need to know like exactly how the mapper is working, because from the service's perspective, it doesn't really care about that. The mapper can deal with that itself, which is, again, this is very clean, right? So everything has its own concern, and we don't need to necessarily worry about that. Alright, so we can also do that from the user to maybe like the user DTO. Alright, so for example, we can do, oops, let me click that. We can do public user DTO, and then say from entity. And we can pass in a user. Okay, so this is the opposite direction. So remember, like, the user may have a password that I don't want the end user to know about. So we'll do user DTO equals new user DTO. And then from there, it's just basically like getters and setters. Let's go ahead actually and add that stuff to here. So we'll do data, no args, all args. Don't you just love Lombok? It makes that so much simpler. All right, and then maybe we don't even care about, we may want the front end to know the ID. That might be something they would need to know. All these things, right? So DTO.get, that's set. I'll go ahead and write them all out, but they're just basically setting each individual thing to like user.getAge. So as you can see, we're just mapping from one thing to the next. User.getState, DTO.set ID, user.getID, DTO.set email, user.getEmail, DTO.set username. I haven't done that yet. User.getUsername. DTO.set address. I think we have address and phone number left. And again, this is just mapping, right? So we just return the DTO, and there we go. So now we were able to, for example, in our service, I wouldn't maybe necessarily want to return the user. I may want to return the user DTO. And that way, I am pretty clear that I'm not going to expose anything like a password, right, to the front end. So we'll redo this, all right? So we'll take the user, and then we'll save it. All right, and then we'll say user saved user is equal to this, and then we'll return user mapper dot from entity saved user. So that way we will pass back up, but it will be in DTO format, and then we'll have to change the controller. Okay, because it's gonna. We also probably would want to grab that and send it back up to the clients. That way they have the added information. So we can do user DTO is equal to this. So the users that register user DTO. All right, and then we'll just change the response entity over to that. Okay, and here we can just turn back bad request, like so sorry. And then later on, when I show you a nicer way of doing like error messages, we can handle that then. But all we did was a little bit of change. We just changed this over to user DTO, and that way, when we actually use this, I'll restart Spring and we'll just see how this works. But like I said, when we reuse this, that way we're not exposing anything we don't want to the client. All right, so I'm going to put. We're back at here. We're going to do a post. We're going to see what happens, and there we go. Okay, we got the DTO back, all right? So here, that's what it's kind of nice, right? So like there's no chance, right, someone would accidentally pass the password back up to the client. Maybe later on we want to change certain things so that only certain things come back for this response, but DTO separates, right, the client's representation of data versus the representation of data in the database. And I think hopefully now you understand a little bit better about what that means. All right, so we made a mapper, okay, which is just a class. I use the at component so that it's injectable, and the mapper is the place where we'll have all of the mapping. So instead of doing it every time we have a service, instead we're just going to inject the mapper and then have it basically switch our DTOs back and forth. All right, so that is one way of handling this, so it's a little bit cleaner rather than just doing it in every single service method, which again, we only have 2 methods right now, but as our application grows, it would have gotten very tedious. All right, let's do a little more refactoring. And one of the things that's been on my list to refactor is these exceptions here. Because typically we don't like to use the built-in Java exceptions because they're for other situations, right? We're making an API, we would like to have our own exception. So for example, we've been throwing this no such element exception for if we don't find something. So just to kind of refresh your memory, we have this, for example, delete book by ID. So if we're trying to delete a book by its ID, but we don't find a book with the ID, and so in which case we would throw an exception, which is, hey bro, like you're trying to delete book number 10, but there is no book number 10 in the database. And so we will return a 404 not found in case that exception is thrown, letting the client know that the resource they're looking for doesn't exist. However, I don't really want to use the built-in Java exceptions. I want to kind of use my own. So let's make a package called exceptions. It's called exceptions. And let's make our own custom exceptions, because these custom exceptions will come in handy. They will have the meaning that we impart on them is a meaning we can decide. So we don't have to like take the built-in Java exceptions and jury rig their meaning. We can just make one of our own. So we'll do new Java class, and we'll call this entity not found exception. Now every workplace is probably going to name their exception something different. So I'm showing a very general example and then applying it in our API to show you the benefit of what Spring gives us to handle exception handling. But again, your job may name things differently. All right, so we have this entity not found exception, and we're going to have it inherit from runtime exception, because that's what it is, a runtime exception. All right, and now we've inherited from it, we're going to do the constructor, and we're going to have a message that you can put in, and we'll do call the base class and pass the message in. All right, and that's all we need to really do for this exception. There's nothing like super special that we need to do here. All right, so now what we're going to do is we're going to use this exception instead of the no such element exception. So we're going to do a little bit of switcheroo. So we'll do entity not found exception. Entity not found exception. There we go. And I'm going to go ahead and change everything over real quick. So we did for delete book, we had it, and I'm going to change it for update book. We had it, and then we had I think those are the 2 places currently in the book and like the books where we actually use those exceptions. So here is the thing. We can go ahead in the controller and update it, all right, and change our catch, all right, in both places, here and here, inside the update and delete. The only thing I would say is that this still isn't super extensible. What I mean is that you basically have to kind of write the same code over and over again. Try, catch, return new response, and then the HTTP status not found. Same thing here, right? And if we have a lot of different endpoints, it becomes very repetitive. So if we have a large API, there's going to be plenty of occasion where someone will look for something and have it not be there when we return a 404. What I would like to do is that, hey, if my Spring Boot application throws an entity not found exception, right? So like essentially be more general. If the exception is thrown anywhere, here's the response I would like to give. Because if you look at it, right, the response we return here in our update is no different than the response we're going to return here in our delete because, well, it's, 404 not found. So the next step that we're going to do in the next video is be a bit more global in our error handling. So instead of essentially saying that I have to manually do try catches and etc., we're just going to have it to where, hey, if this exception is thrown, then we will be able to funnel all those exceptions into one area and return a response. All right, but before that, we just need to go ahead and make a special exception. So to review, we made an entity not found exception, which inherits from runtime exception. And there's nothing really super special about the class. It just inherits from runtime. We have a constructor with a message. We went to the surface and we changed everything over to entity not found exception because that's what is happening. We're not just taking a pre-built Java exception and jury rigging the meaning. We're actually creating one that we impart meaning to. And the next step, we're going to do a little bit of global error handling where everything will be funneled to one area. All right, one thing I want to talk about was with error handling, right? And we are getting somewhere, just be patient. But one thing I want to talk about with error handling is simply the fact that we want to try to standardize how we give errors back to the client. Now, what I mean by that is, let's say something goes wrong. So, for example, we have it that if you try to search for a book that doesn't exist in our database, we're going to give you a 404 not found. So if I do this, I get 404 not found. Okay, that status code exists to let the client know what was the result of their request. That's fine, but you'll notice that there's actually no other information about this. So basically the client just gets a 404, but they get no other context. And again, that's okay. 404 typically, I mean, they can figure out what 404 means in this specific circumstance, but there are probably going to be other errors that occur in our program where it would be nice for the client to know like where they went wrong. So for example, let's say I put something that's not an integer in here. All right, so the endpoint is expecting an integer after the slash. I'm going to give banana. All right, so I'm going to go ahead and move this, and I'm going to get 400 bad requests because I'm expecting a number and I gave you a string instead. But notice how Spring Boot automatically gives us a JSON object with like a timestamp, the status, an error, and a path. So this gives some more information as to what happened with the request and what specifically went wrong. So the client will know, here's the time, right? Was the status I got, what was the specific error, and what endpoint did I hit? Because maybe on the client's end that they need to do some logging or whatever it is they need to do in order to figure out how to make things work on their end. Remember, the client, like again, you might be building a full stack application and you will write the client yourself, so you'll know your own errors. But if your API is following standards and eventually you may want other people to use your API, they're not going to be able to read your mind, right? So we like to be able to provide a little bit more context to what the error message is, especially for things like 400 bad requests, because that's very general. Now, there is a standard that people have come up with over the years, and it's called problem details. And if you're interested, this is actually the problem details document that I found on the internet. And problem details, essentially the idea is, hey, we'd like to standardize the error response for APIs. So that people can, as long as everyone uses the same structure for problem details, then all we have to do is just everyone does the same thing, and so everyone can expect how to react. All right, and so we're going to actually use problem details ourselves because that's just a good practice. Do you have to? Absolutely not. You could, I have seen APIs where they don't give custom error responses. They just go with what they want to do. That's a thing. Some people use problem details. Some people make their own special error response. That's also cool too. I'm just doing problem details because, well, it makes a lot of sense to use a standardized way. Alright, so since that's the case, since we kind of have an understanding of what the problem we're trying to solve, the other problem we're going to try to solve is the fact that I'm repeating myself in my controller. In my book service, we updated it to use my new entity not found exception to indicate that, hey, you wanted to go find a book, but that book doesn't exist in the database. Sorry, bro. And so when that exception is thrown, the controller will catch the exception, but I'm writing a lot of redundant code here. I have a try catch, and I'm running delete book, and if everything goes hunky-dory, I'll return no content, but if there's an exception, specifically entity not found exception, I will return 404. I'm doing exactly the same thing with update book. If you look at this code, it's basically the same thing, except for, you know, the status on line 82 and then the actual service I'm using. Everything else is pretty much the same. So I'm repeating myself. What if I told you that there is a way for Spring Boot to centralize all the error handling so that whenever someone throws an exception, like any not found exception, we will always give a 404, and not only will we give back a 404, we will have a very standardized error message so that the client knows specifically what happened, like what error did they get. Not only will this work with our any not found exception, we're going to create exceptions for all sorts of stuff that could go wrong in our Spring Boot application, so that way the client is not left in the dark. When they send the request and let's say something goes wrong, they can figure out, you know, is it on their end, is it on our end, what specifically went wrong. So it makes it easier for them to debug their own code. Alright, so now I think we understand the problem that we're trying to solve. So the next lesson I'm going to show you how to use what's called controller advice in order to accomplish this. Alright, as promised, we are going to have a global, centralized way to handle our exceptions so that we can give back standardized responses. So in our exceptions package, we're going to make a new class, and we're going to call it Global Exception Handler. Okay, this will be the class that all the exceptions will flow into. And we're going to put an annotation called Controller Advice on the top. So what controller advice basically means is, hey, if there is an exception thrown in the service layer or in the controller layer, if the controller and the service don't handle it, I will. So what that basically means is that it's going to look, and this is why these annotations are important, right? So we put this service annotation on the book service so that it's marked as a service. And the same thing with the controller. It's marked with this REST controller right here. So it does impart abilities onto the class, but one thing I also want to point out is that also lets Spring Boot know like what part of the application is this class. So therefore, Global Exception Handler can use a controller advice and keep an eye on those classes for us, just because we put the annotation on top of it. So now, what do we put inside here? Well, we're going to put handlers. We're going to have some way to say, okay, cool. If this exception is thrown somewhere in the service or the controller, and the service and controller don't handle it themselves, what do you do? We're using another annotation. We're going to do exception handler, and we're going to say what exception are we handling, in which case it's going to be entity not found exception.class, the class itself. Then we're going to use the problem details. We're going to make an actual method that's going to return a problem detail, which actually is built into Spring Boot because problem detail is a standardized thing. Okay, it's a standardized way to return errors from an API, so it's built in. So we'll do problem detail, and then we'll call handle entity not found exception, just because that's what we're going to name it, and it will take in the entity not found exception, and it will take the request that's coming in. Okay, that's our method signature. I'll make a little bit more room so you can see the full thing. All right, again, we're using the annotation to say, hey, which exception does this method handle? This one. Cool, I'll take that exception in as a first argument, and then the actual request that's coming in. Okay, and then what do? We're going to fill the problem detail in with the necessary information. So we're going to do problem detail, and we're just going to instantiate it. Okay, and you'll notice that we need to actually give it a little bit of data. So you hover over it, you'll see it has protected access. So we won't be able to directly use it this way. What we're going to have to do is we're going to use the factory method. So we can do problem detail dot for status and detail. All right, and then what we'll do is we'll get the status of the exception and the reason. So here we'll use that enum we've been using. So we'll do HTTP status dot not found, and then we'll also get the message from the exception itself. Okay, we're going to pass up to the client. So we're going to use, this is a static method, so it's a static factory. And then so I just wanted to show you couldn't just do new problem detail and go on with your life. This is the way which you would actually form them. And then the problem detail has several parts to it that we need to give. So we do have the status, okay, which is the HTTP status code. We also will need the type, title, detail, and instance information. Now, why do we need these things? Because that's in the documentation. That is what problem detail is. If we look back at the documentation for problem detail, it says member of a problem details object, and it tells us type is 1, status is 1, title, detail, instance. All right, that is what the JEDI Council for APIs has decided that is going to be in the problem detail standard. So we have to follow the standard. Don't worry, it's nice because following the standard means that the client will know exactly what they're getting back, and everyone will be on the same page. So we'll do set type. Now, essentially, this would be the documentation that the person would go to read to figure out what the thing, like what went wrong. We don't really have any actual website, so I'm just going to put like a fake example.com/problem, right? Some sort of string to basically say like, hey, like this is where you would go. All right, always be a URI. That's fine, we'll create a URI. There is URI.create. URI.create. Where are you? There we go. And then we can put the string in here, example.com/problem. All right, it's basically like where would the client need to go in order to fix their issue. All right, then we can go ahead and set the title, problem detail.set title, and we'll just say resource not found. Like, hey, this is what went wrong. It's just something quick. We set the details already, so we don't need to do that. And then problem detail set instance. All right, and what we can do with this, so we can get the description of what happened. So it's about the request itself. So what we'll do is we need to create a URI, so we'll do URI.create request.getDescription, and we'll put false in here. All right, so I don't want to include client info. I just want to include the basic info. And then now we set up the problem details, we can just go ahead and return it. All right, so we've got this going now. We've got the global exception handler, which is annotated with controller advice. And then we're telling it, hey, if in the controller or service somebody throws an entity not found exception, then go ahead and come here and run this, and we're going to return the problem detail as opposed to our own stuff from the controller. So let's go ahead to our controller. Let's refactor this a bit. So let's scroll down a bit. Where's the first one? Okay, cool. So now instead of doing this, we'll just get rid of all this boilerplate code and do this stuff that actually makes sense, right? Go and try to delete the book. If everything goes hunky-dory, go ahead and return a 204. And we'll do the same thing with the put. I'll take this out of the try block and then just get rid of the duplicate code. And now it's a lot cleaner, right? So it looks, the actual like returning of an error is not something that the controller is necessarily doing. It's all centralized in the global exception handler. So now let's take a look and see if how this looks. All right, so I'm going to restart my API, and we're going to take a look and see how this looks in Postman. So here we are in Postman. I'm going to attempt to delete a book where it's not in the database. So I have my delete verb and doing /API/book/10, right? So there should be no book by that. It should throw the exception and then return my problem details. I'm going to go ahead and hit send. Well, there we go. And now we get a 404 not found, but we also get a little bit more information, all right? This is the problem details, right, that we did before. So we get to see like, hey, like this is the type, this is the documentation they would go to, but we don't really have any. This is what I put for the title. Here's the status. Here's the details of the message. And then here is essentially like what the endpoint did you hit to actually get this error. And so the client will be able to consume this JSON object because it's in a standardized format and do what they need to do with it. So now we kind of see how this is very, very clean. Okay, so problem detail standardizes the way that we get back error message, and then we go back to IntelliJ. The global exception handler allows us to funnel all of our exceptions into one area, so that way we can standardize the way in which we give back the error to the client. And now my controller does not need to have a bunch of duplicate code. All I need to do in the controller is basically hand back the right HTTP status and call the right service method. And the service can do its thing too, and all the service needs to do is throw the right exception under the right circumstances that the global exception handler is going to pick, as long as I have a handler set up for it. So now I have a really, really clean separation of concerns between my different parts, and I don't have to repeat code. So this global exception handler, thumbs up. You will very much enjoy this in your Spring Boot career. Another common use case is using this exception handler to deal with validation errors. So for example, let's say we go back to our user registration. So let me go back to our user controller, and we had this register endpoint, and we had a DTO, and we checked to see if that DTO was valid. So the user's registration DTO had all these annotations here to check to see if things were supposed to be null. The username is between 8 and 20 characters, these sorts of things. So we want to be able to let the client know, hey, you sent us this request with the body of the request as the user registration, but you missed these things, or your username's too long or too short, or your phone number is not valid, or all sorts of things, right? Because the many things could go wrong when the user tries to send us this information in the body of their request, and we want to make certain that when they do, that we let them know what went wrong in a clear and concise manner. So our global exception handler can deal with that. And since we're using the Java validation, we actually already have a built-in exception that it throws when things are invalid, so we can kind of intercept it. So what we'll do is we'll do an exception handler, and it's going to be method argument not valid exception. Okay, method argument not valid exception. We didn't make this, all right? So this doesn't come from us. This is not custom, all right? This is from the Spring framework.web.bind. And so, but it's cool, right? We can use it. It's part of the validation. And so we'll do public problem detail, and we'll do handle validation exceptions, method argument not valid exception, and then the web request itself, just like last time. And I will make some room so we can take a look and see what's going on here. All right, so what we'll do is we will first make a list of the errors. Or what we could do is a couple ways we could actually do this. What I want to do is, first off, because they could get multiple things wrong, I'm going to make a list of strings to basically say, hey, this is what you got wrong. So we'll get the exception, and we'll have a thing called binding result, which is basically, hey, you went through this object, in this case let's work user registration DTO, and you checked every property, and you kept track of which properties did not pass validation. All right, so let's get binding result. And then we will do get field errors. All right, so give me any errors you found. Okay, while you were looking. And it's okay, cool, I found some errors. Actually, let's put this back over here. Yeah, over here. And then we will stream those errors. I'm going to map them, and we'll do field error lambda. Oops, I need a D there. Okay, field error dot get field, and then we'll do plus field error dot get default message dot collect. We'll just do to list, actually. We'll be modern and do to list. So what this is doing is basically saying, hey, you did some validation, you checked to see which properties were correct and which ones were not. Could you give me a list of them, tell me all of the field errors you got, and I'll make my own message from them. And then from here, we're just going to do what we did before with problem details. So problem detail, thank you. Use our static factory, or status and detail. All right, so if they have a validation error, it's a bad request 400. Okay, so remember, the 400 range is the client made an oops. 500 range is the server made an oops. So if they send us invalid data, that's their problem on their end. They need to fix it. All right, and then so we'll do the status, and then we'll actually take all the errors in for the details. So we'll do string.join with a comma, and then pass that list of errors in. So that way they get that whole list of stuff. Again, I will make this wider so you can see. All right, and then for the rest of it, honestly, it's the same thing we just did up top over here, right? So it's like problem detail dot set type URI dot create, and then where they would go. Maybe like we have like a little website or something, and then problem detail dot set title, validation error, and problem detail dot set instance URI dot create, and then request dot get description false. And you could, I don't know, honestly, you could like have some sort of method to consolidate this problem detail stuff. I'm just doing it for expediency, and we can return the problem detail. All right, so what we did was we gathered up all of the validation exceptions, and we're going to package it into one nice string and then let the client know, hey, here's where you went wrong in your request. All right, let's take a look and see how this works. I'm going to go ahead and run this, and then we'll try it out in Postman. All right, here we are in Postman. I did /API/user/register with a post, and you'll notice I only have the name and email. I'm missing actually quite a few things that should go into the registering a new user, but we're going to send this half-baked request anyway. Oops, we got 400 bad requests, and now we got validation errors, and we can clean this up a little bit, but you'll notice that this is the string we wrote. Age must not be null. Username must not be null. State must not be null. This must not be null part, this thing here, if we go back, all right, is the default message. So each validation error has a default message, and so what we're doing is we're just basically getting that. All right, so we can even like put a little space in between here. I should have done that, but you'll notice that now the client can like be like, oh, okay, so like I forgot the age, and I forgot the username, and I forgot the state. And then you can even put, whatever validation measures you want there using in the annotation. So here they can get a full glimpse of how they went wrong in their request. This is also another very common use for the global exception handler, because you might have a lot of different classes that have a lot of different kinds of validation, and having them all funneled through here and to give a standardized response is actually quite powerful. All right, so remember the method argument not valid exception is an exception that we didn't make. It's built in. Okay, it's part of Spring Boot because we're using the validation stuff that we did earlier with all the annotations. We get the binding result and get all the errors from the validation. We create a string out of all of them and pass it in with the problem details that the person on the other end can read where they went wrong with their request. All right, so we are going to deploy our Spring Boot API up onto the internet. And what deploy basically means is, hey, I'd like people on the internet to be able to use my application. I don't want to just run it on my computer and, I don't know, let people borrow my laptop when they want to see my work. I need to put my work on the internet so that everyone on the internet can see it. So we're going to use a service called Heroku because it's pretty much free. And it's fairly easy to use. I'm not going to say it's the easiest to use, but it's fairly easy to use. And it's great to get your stuff up on the internet if you're writing in Java, all right? So it's already understands how Spring Boot works, and it makes the configuration a lot easier. So what you're going to need to do is you're going to need to go to Heroku.com. You're going to need to sign up for a Heroku account, all right? Now, that means you're going to need to give your name, email address, language. I am going to say from off the rip, you will need a card on file. Okay, you will need a card on file. You won't. We're not using anything that costs any money, unless of course you want to like actually launch an actual application, actually have real people use it, and that's your business. But for the purpose of this tutorial, nothing I do will actually have anything that costs any money. However, Heroku will not let you use certain things unless they have a card on file. I wanted to make sure that was absolutely 100% clear from the beginning. And the second thing is they will require two-factor authentication. So hopefully you have some sort of authenticator app because that's going to be necessary in order to sign up for them. They won't let you verify or move after a certain point without it. Okay, so go ahead and get Heroku. So sign up for it. Go through the whole rigmarole of the two-factor authentication. It's not really that big of a deal. But once you're done with that, we can take a look at what Heroku actually is. All right, so this is Heroku, and what Heroku is allows us to create applications and then to also add resources to those applications like databases, for example. So essentially what's going to happen is we're going to create an application and we're going to take our Spring Boot application and kick it up to Heroku. And we're going to do that through GitHub. So that's actually kind of the cool thing about Heroku is that you don't have to use any of their special stuff. All you gotta do is essentially put it in a GitHub repo, and that's pretty easy. And then when you push it, you'll be able to use the Heroku command line interface, or CLI, in order to do that. And then also Heroku allows us to get requisition databases that we can use with our applications. So that way we can have a database, because again, we can't use our local database we've been using for the course, because that's not online where people can actually get to it. It needs to be up in the cloud, okay, on the internet deployed. All right, so that also means you do need the Heroku CLI. If you Google install Heroku CLI, you'll easily find this page from the Heroku Dev Center. And what it does is it gives you instructions on how to install the CLI. You will need to have Git installed. So if you don't have Git installed, which I can't imagine you don't, but let's say you don't, go ahead and install Git on your computer. You'll definitely need it. This has instructions for both Mac OS and Windows, so you'll need to do whichever one is in your particular case. All right, and this is a pretty good article about how to actually install the Heroku CLI on your computer. The Heroku CLI is mandatory. So is Git. They are both mandatory. You can't get around having them. They are both necessary in order for us to deploy our Spring Boot application to the internet through Heroku. So you need to make certain that those two things are set up and follow the directions and it gives you directions on how to confirm that it's properly installed. All right, once you got those things installed, then we'll be ready to create our Spring Boot application. We will need to make a few changes to it, nothing drastic, and then we'll be able to push the application up to the internet, then requisition a database, and then we'll actually be able to use our API. And not only that, other people on the internet will be able to use our API. We're going to need to do a little bit of configuration for our application in a bit. But what I first want to do is I want to make certain that everything builds, all right? So make sure everything builds, because otherwise it's not going to work. And we're actually going to go ahead and package our API and get it ready for Heroku. And what that basically means is we're going to create a jar file, all right? And we haven't really done this before, but let's make certain that we can go ahead and do that. So what we're going to do is we're going to do run, and then we're going to do, actually, where are you? Actually, you are in view. There we go. Tool windows, view, tool windows, and we're going to find Maven, all right? Because we're going to use Maven to package our API. And so what it should bring up a menu like this, and these are all the Maven commands. And one of the cool thing about IntelliJ is that it gives you the Maven commands in this nice format. So we're going to do clean first to clean our project. Okay, just make certain it has all the dependencies it needs, and then we are going to go to package and make sure you double click it. That should kick it off. All right, so it should go ahead and run. You may have problems with the test. It's possible for some people that when they run their test, it might have a problem. If it is, what you can do for right now is you can just comment out the test. All right, so you can just go ahead and do that for right now. I'll show you later what we can do about that. If you're having problems with it, because right now I really just want to deploy, and the test is not really necessary in order to deploy. So if you're having problems with it, and it's red and stuff, it's probably the test, and you can just comment it out for right now, and then redo the package. All right, now what package does, it creates this little target folder, okay, and it has our snapshot.jar here. All right, so you're going to see snapshot.jar with the name of our application, and then the original. So this is basically sort of like the condensed version of our application. It's all the code compiled down to one thing that can run. All right, so we've had all these files, but now we've got them all kind of put together in one neat little package. All right, so we got a couple more things to do here, but not really too many. What I want you to do is I want to show you where this goes. We're going to create what's called a proc file. So I want it in your source, not in your source folder. So if you can do this with your source folder, your proc file should be outside of that. It should be at the same level as your POM XML. And you're going to put your proc file, and you're going to put this. You're going to put web. Okay, let me see if I can make it a little bit bigger. There we go. So you're going to put web, java-jar target, and you're going to put the name of the jar file. So like this is the snapshot jar file right here, right? You're gonna put target slash and then exactly what's written here, okay, into this file. And this basically what this lets Heroku know that like this is the jar file, like this is what I want you to get, and this is a web application. All right, so make sure proc file, capital P, PROCFILE. Okay, it's just that's all you got to write. There's no extension, and you put this inside the proc file. One thing you also probably will want to do is create a system.properties file also in the same level as your POM XML. And here I want you to put java.runtime.version equals 17. This is so that Heroku knows what version of Java to run when building your application. Otherwise, it's going, I think we'll default to 8, and that definitely won't run anything what we're doing. We're definitely using features that have been added since Java 8. So go ahead and make a system.properties file in the same level as your POM XML. So they should be like, the same length over. And then you need to put java.runtime.version equals 17. And once all that stuff is finished on this end, we should be able to push everything up to Heroku through the command line. So what you're going to want to do is you can actually, the folder that contains our application, you can right click on it, and I think we can actually just go ahead and open it in the terminal. All right, so it's open in, and then there's terminal. All right, so you should be able to Heroku log in here, Heroku log in. Okay, it should pop you to open a web browser, okay, to actually log in. So you'll do that outside of here. Okay, I'm already logged in, obviously, so you'll need to make sure that you're logged in. It doesn't take too long to do, just make certain you're already. This is why it said in the last video you need to be set up with Heroku. Otherwise, it's going to be pretty rough. So we need to actually create the application that will be the house, or where our Spring Boot application will live in. So Heroku is going to be the first command, create, and we're going to call this spring-first-API. No spaces. No spaces. Okay, so Heroku create, and then the name of the application, we're going to call it Spring First API. And we're going to hit enter, and then you're going to just kind of wait for Heroku to do its thing. It won't take too long. All right, so what it will do is it will create an application in Heroku and also create a GitHub repo in Heroku that will be our remote. All right, so we will need to make a, we'll need to make a GitHub repo. We also can make our database in a moment. So let's do that because we will need a database. We're going to use JawsDB Kitefin, which is a MySQL database, which is free. So Heroku add-ons create JawsDB Kitefin. Okay, Heroku add-ons create space JawsDB Kitefin, and that's going to be our database, right? Let's see. There's a flag. That's right. We need to tell what app that this goes to. All right. So my apologies. Should be Heroku add-ons create JawsDB Kitefin. We'll use the A flag, and then we'll put the name of our API, Spring First API. All right. That way it knows which application the database is supposed to go to. All right, so it's going to take a second to actually requisition the database. It's not instant, which is fine, no big deal. We'll check that out in a moment. All right, but what we can do now is go ahead and we're in our folder that our API is in, so we're actually going to use git init to make it to a git repo. Okay, let's just say initialize empty git repo. You're going to add everything, and you're going to commit. So hopefully you know some of the basic git commands. So we're going to call this initial commit. So the first thing I did was git add dot. There's a dot here. This is not just for show. This is everything. So I added everything in the folder, and now I'm committing it. Okay, everything's committed. And now whenever we push to Heroku, what it will do is it will be like, oh, you pushed, right? You made some changes in GitHub, and you pushed them. I can actually, Heroku can actually take your changes and be like, literally run your application, like build your application. It's actually pretty cool. So we can do git push Heroku master, because it's the master branch. So let's see. If you get this, that's not a big deal. What you can do is Heroku git remote -a, and then the name of our application was Memory of a Goldfish, or Spring First API. Spring First API. Okay, that will add our remote, the GitHub repository. Okay, cool. The remote is set. All right, so now we can try that again. We can go ahead and do git push Heroku master. Okay, cool. So now you see it's pushing, and that it actually is literally like detecting it as Java, and it's actually building our application. Okay, and downloading all of the different dependencies that we need from Spring and whatever else we've got. So literally, we just push the code up to Heroku, and it's going to take all of our files, and it's going to attempt to run Spring Boot on the internet. It won't succeed because we don't have the database and stuff set up. We'll need to do one more step to get that all going, but this will be the initial push. All right, so it will say deploy to Heroku. Again, it won't be running just yet because without the database, our API doesn't really do anything. But once we get that going, we'll actually have a functional API. All right, so hopefully you were able to put in your system.properties, okay, a proc file with the jar, and you use Maven to first, you go to View, Tool Windows, Maven, which will bring up the Maven side panel here in IntelliJ. You'll clean your project first and then do the package. Remember, if the tests are failing or giving you a problem, just go ahead and like comment them out for the moment, okay, just so we can keep going. That way you don't have to like sit here and fiddle with that too much. And then you need to make sure you're signed up for Heroku. Make sure you do Heroku login at first. Then you're going to create a Git repo, and you're going to push everything up to Heroku with git push Heroku master. If you don't have the remote set up, it's supposed to set the remote for you, but if it doesn't, you can always set up the git remote with this command, Heroku git remote -a spring first API. And hopefully, with all these commands, I know there's quite a few commands. There's going to be a thing I'm going to include with the lesson, all the commands in order, all right, so that you know what you're doing. And then hopefully you should have a Spring application, not quite working just yet, but a Spring application deployed in Heroku, and I'll show you what that looks like. If everything went well, when you log into Heroku, you should see your Spring First API. This is the application with a little like purple cube thingy. If you go into it, this is it. This is like, it will actually have like the activity, right? Build succeeded, deployed. All right, and so we also should have installed add-ons. Since this JAWS DB MySQL, we were able to requisition a database. If you look at the resources tab, this is our database. Okay, it's a free MySQL database that Heroku allows us to use. It obviously doesn't have all the bells and whistles, but it's good enough for a deployment, right? To practice deploying. And so the next step is, how do we make certain that our application knows to work with this database? It's going to need the connection string. So what I want you to do is, I want you to go into the database that was requisitioned. Okay, it will just click on it, and it will go into it. Okay, and it will have like a little bit of a dashboard. Okay, it will tell you the host and the password and all that good stuff. I want you to get this connection string right here. Okay, copy this and put this in Notepad or put it to the side. We are going to use it in the next lecture when we set the database. Okay, now if you think about hacking me, this won't exist after this is done, so don't even think about it. But this is the connection string for your database. I want you to put this aside so when we set the database in the next lecture, you'll have it ready. All right, let's get the database set up. So if you didn't actually set up the database with the command line, that's absolutely fine. You can still do it. What you can do is you can go in Heroku, from Heroku, you can go find your application, Spring First API, and click on it. Then go under Resources, and you can click Find More Add-ons. All right, this is how you add resources like databases. So if I click on that, as you can see, Heroku gives us a lot of different options for what kind of database we can do. You can find JAWS DB MySQL and click on that, and then you can hit Install JAWS DB MySQL, and that will also set up your database for you. Again, it will take a few seconds. It's not going to be instantaneous, but that is one way of doing it. And so here we go. We've got it. Now, what do we do in Spring Boot? Because Spring Boot is going to need to know how to connect to this database because we're using Hibernate to make all of our tables. So we definitely need to have this set up. So there's a couple things we need to do, nothing major. We're going to first go into our application. I'm going to make a new package inside the main package, and I'm going to call it config. I'm going to create a configuration file that's going to hold some data for me. Essentially, we need to take Heroku's connection string and transform it into something was like a JDBC connection string, essentially. So what we can do is we can create a new class. We're going to call it data source config. And I'm including the code in this lecture because I do not expect you to follow along while I do this. I basically just wrote out all the code myself, so that way you don't have to. And we can go ahead and I'm just going to go ahead and put this in here for the sake of time. All right, and I'm just going to explain what it does. All right, so data source config. All right, it is angry at me. That's because I overwrote the initial package. Silly me. All right, there we go. So we have a data source config. This is a configuration bean. So you have this configuration annotation, which means this is, hey, this is to configure stuff. All right. And what we're configuring is the JAWSDB URL. And you're like, what the heck is this JAWSDB URL thing? If we go into Heroku, then if you go to your JAWSDB, which should be requisitioned by now, okay, you can look into it. Actually, I want to go to settings. All right, and then there should be reveal config vars. And what you'll see is JAWSDB URL. So these are called environment variables. Essentially, they're variables that represent really important things in our application, like connection strings to the database. I don't want them floating around where hackers can easily see the connection string to my database because bad things will happen. I would much rather a hacker see JAWSDB URL, which is completely meaningless from their perspective. So this is an environment variable, and we need to basically, what I'm doing here is I'm saying, okay, cool, we're going to grab the JAWSDB URL and we're going to use that. And I do some jujitsu here to get the info out of it because, again, the connection string that's given to us through Heroku is not exactly the way Hibernate wants it, so we're just sort of like rearranging things. You can look at the code yourself if you would like to look at it. It's not a big deal. I'm just grabbing the username and password and creating a new a connection string out of it that's more in line. It begins with JDBC MySQL, all right, so that way it's able to use it. Now the next thing we need to do is we need to change the application .properties, okay? So we're going to go ahead and do that. All right, and what I want you to do is I put it up here. There's a couple things I want you to do. For spring.datasource.url, you're going to put JAWSDB URL. See how this is a variable? So when we put this code into Heroku on the internet, what Heroku will do is it will look for this and say, oh, this says JAWSDB URL. Awesome. This also says JAWSDB URL. I should take that and replace it with this. Okay, and that's Heroku's going to do all that for us magically. I set the driver, I set Hibernate to update, MySQL dialect. The last thing I want you to make sure you absolutely do is server.port equals $port 8080, all right? Because we want to make certain that Heroku knows what port to run this on. If this is not there, you will get an error. So take a second. Again, I have a picture of this along with the lesson, so that way you don't have to type it, you don't remember all of this. I most certainly did not. I looked it up, okay? I'm not just letting you know that no one has these sorts of configurations just like memorized. You do this once, then you never do it again. All right, so now that we've got our application properties set up and we have a data source config, then our application will be able to actually connect, okay, to the database when it's in the internet. So we're going to go back to View, Tool Windows, Maven. We're going to hit the clean. Okay, do Maven clean. And then we're going to package everything. And remember, if you have to comment out the test, then please do so. Now, this package may be fraught with errors, okay, usually because of the test. One thing that you can do, okay, so the test ran, so that's nothing that you have to worry about. If you're having problems with the test, what you may have to do is you may have to put this environment variable into your config. So you can go up to Run, and then you can find Edit Configurations, and then you can put your environment variable here like I've done it already. So here I put JAWSDB URL equals, and I just pasted everything else in here. So this is where you would put environment variables in your application, all right? In case you're having problems, you probably just need to put this here, all right? And that way it should go. You want to make certain that this package step is a success. Okay, if the package is not a success because it won't actually push up to Heroku properly. Now, we've done all these changes. Let's go into our terminal, and let's go ahead and git add git commit -m database stuff. I know very informative commit message, git push Heroku master. So we're going to push all this stuff up to Heroku so that it will be deployed on the internet. Remember, deploy means take a copy of my code, put it on the internet so people on the internet can actually use it. If it's not deployed, only person that can use it is you and whoever you give your laptop to. Okay, so we want to have our stuff be on the web. Okay, it will take a second. It's no big deal. Okay, and it will give you a link. This is the link to your API. This is the base URL for your API. Before, we used localhost port 8080. So instead of doing localhost port 8080, you are going to do this. So go ahead and copy it. Now, one thing you can do if you're having problems is you're going to have to debug some things. What you can do is you can do Heroku logs 2 hyphens tail. And what that will do is that will bring up the Heroku logs for you to see. And the Heroku logs will allow you to figure out like what's going on. And if you look at it, it looks just like the terminal in Spring Boot. Okay, and it is. All right, so you're able. If you're having errors, you'll need to go and do this command to actually look at stuff. If you want to exit, do Control C, and yes, I want to terminate the batch job. Again, that command was Heroku logs 2 hyphens tail, and that's how you can actually see like did Heroku have a problem building your Spring Boot application and getting it to run. All right, usually the problem is either the port, you forgot the port, okay, or you didn't set JAWSDB URL correctly. All right, so it needs to be exactly like what it is in Heroku. All right, so from here we can type Heroku open, and that should open up a browser. Now again, this is an API, so there's nothing to see, but it will bring this up. It will see this. There's nothing. It's not an actual error, just to let you know. This is the base URL for our API, and we're going to actually use this in Postman. So we're in Postman, we're going to hit this plus button, and we're going to put the base URL we got from there. Now you're like, well, Jonathan, I didn't see that in the terminal, I missed it. Well, it's no problem. We can go to Heroku and we can also find it. Okay, here's Heroku, here's our API, our application, and now you're wondering, well, where the heck is the actual URL going to be? First off, you can always open app, and that will actually take you to there. There's a button up here to actually take you straight to it. You also can go to settings, scroll down a bit, and you can see your app can be found at blah, blah, blah. And this is where if you wanted to buy a domain name, like if you didn't like this, the default domain that Heroku gives you for free and wanted to buy one yourself, you could. All right, so let's open up Postman. Let's give this a try. All right, so our first route was /API/books, and so I'm going to do get request, and I should see an empty array, because we don't have any books in our database. I'm then going to create a JSON payload, and I'm going to have title be Hunger Games, and ISBN. I have no idea what the ISBN for that is. We'll just put 1234, and then we'll do name, or what was it? The other one, I think it was author. Okay, we'll put author in here, and I actually don't know who wrote the Hunger Games. Somebody. I actually have no idea who wrote that. Let's go ahead and do a post. Okay, because we're sending information, I'm going to go ahead and do that. And it looks like it created it. And then when I do a get, it should appear. There we go, Hunger Games. All right, so now we've got an actual functional API. What I mean by that is your API is on the internet. If someone has the URL and knows the endpoints for your API, they can get JSON data. They can create books. They can get information about books. Okay, you can actually have real people, strangers on the internet, use your API. All right, well, hopefully you were able to deploy your stuff to Heroku. I do have a little sheet that has common troubleshooting tips, because deployment is always fraught with difficulties, because everyone's computer is a little bit different, and that can cause some unforeseen issues to occur. But that's not really a big deal. You are a developer. You will suffer through it, basically. All right, so now we're on the internet. You've got your Spring Boot application online. You don't have to use Heroku if you don't want to. There are other places to deploy a Spring Boot application. I just find Heroku to be cheap and easy if you're just wanting to practice and to actually see your stuff online and in living color.